So today we are going to discussing about the constraints. Okay, so constraints also major part in SQL. SQL. Sir, why we need the constraints? So what do you mean by the constraints? So if you can take this, constraint is nothing but it's validating the data in the backend, and we are going to validating the data in the backend. So validation means suppose something you want to give some restrictions to the front-end users. Understood? Restrictions means so you are trying to avoiding the some duplication, some whatever it is, different things. Like suppose now, whenever you are going to seeing any specific forms in the bank application or whatever it is, you will going to see somewhere stars. What do you mean by the star in the form?
Mandatory.
Right, mandatory. Without that column, is it possible to submit the form?
No.
Right. How you will going to set it as a mandatory? Suppose now star indicates to mandatory, that you understand. Without filling the data you are trying to submitting, it is asking to please fill the form.
Yes.
Mandatory columns. How system is going to knowing in the back, how to set as a mandatory in the backend? So something right, backend, when you will going to set up backend, then only it will going to restricted, right? So front end means just that is user entry form, right? So
Yes.
that is, and one more thing, sometimes we will going to put it into, see, suppose now in the any government departments or something, suppose any university level students marks we are going to entering. Did you see, suppose people are going to entering the marks. Now that particular person got to suppose 30 marks out of 100 marks. Okay. Instead of 30, is it possible to enter 130?
No.
No, but in case by mistake, who is going to entering the details? See, entering details means those people are going to simply they are going to entering the details, hundreds and thousands of people data they are going to entering into the system, right? Yes or no?
Yes.
So the data entry people, they don't know. See, simply what is the data it is there, they will going to look into there and they are going to fill the forms. They will fill the data into the system. Now, by mistakenly, instead of 30 marks, they entered 130. If it is system is taking, so what is the problem?
Evaluation will be wrong, right?
Right, correct. So, see, the person intentionally is not going to entering, by mistakenly is going to entering. See, suppose keep on entering the data, so by mistake is going to entering 130. System is going to allowing to enter 130. What will happen? Problem is coming. So how to avoid that situation?
Okay.
You got me?
Yes.
So that means you should have to put some condition in the background. Okay. Condition in the background. Okay. Clear?
Yes.
Now one more thing. Suppose in the students we have students. So you're going to give the student roll number 1 to you. Suppose your roll number is 10. Okay. Again, 10 same roll number is given to me also. So what will happen in that case? Again, duplication problem will come, and also people are unable to identify why is the two people are same numbers. So that is the reason it is got problem again. So how to avoid that situation? Understood?
Okay.
You got me
Yes.
right? Okay.
Yeah.
Fine. Now, see, some people is going to asking. See, suppose course table is there, okay, and as well as student table is there, trainer table is there. I mean, faculty table is there, and college admissions table is there. So total around 5 to 6 tables are there.
Okay.
Right. In these 5 to 6 tables, now I want to, if I am going to entering, suppose student number, I want to get it all the details of this. That person is how much he paid the fee, and the person is belonging to which branch. The person is under how many faculties are going to teaching. Got it right? So
Yes.
that means how these all the people you can able to link it. So something is unique in all the tables, right? Otherwise
Yeah.
you can't going to connect all the people, right?
Mm-hmm.
So now what do you mean by that unique?
Unique means
See now you,
different.
yeah, let's, you have so total 5 tables, madam. Okay.
Mm-hmm.
So now you have your student table, you have your faculty table. Okay.
Mm-hmm.
In the faculty table, you got the faculty ID. Okay.
Mm-hmm.
That means all the faculties are coming as a unique. Okay. Again, now the same faculty, now suppose you want to see how many particular student is belonging to which faculty.
Okay.
How do you know that? Foreign key
Student and faculty relationship.
right, that is called as a foreign key relationship.
Okay.
Okay, right.
Mm-hmm.
So these all you will going to apply the constraints into, you can apply into column level, you can apply into table level, we can do the alter level also. So
Okay.
that means either you can going to add not null, check, or unique, primary key, foreign key, these relations using alter keyword in the specific column you can apply, or specific the whole table you can apply, or else you can
Okay.
using only alter level, that using specific alter command you can do that. Okay,
Okay.
let's see that examples now. Okay.
Okay.
So just a small examples I'm giving, and we have some assignment on this. I will going to give that also.
Okay.
Let's finish this first, and then I will give. I hope you understood why we need the constraints and where we are applying most of the cases.
Yes.
And one more real-time example is if you are going and applying for any driving license, sometimes they are going to putting mandatory documents.
Okay.
So at that time also we can use. Right. So here create table. This is a table level constraint. See now
Okay.
here you are seeing 3 type of levels, right? See in the here table level, column level, okay, alter level. So now we are going to applying this is into specific column level. Sorry, not in table level. It is column level. So where I put the not null constraint?
On the column.
Yes, this specific column level I put it. Now see here. So here don't think it the tables are very small. Okay. Always
Okay.
tables are big. Okay. Just for your example and understanding in the starting level, we are going to take in small tables.
Can
So
you just explain 1 minute alter level?
it's come. Okay. All examples will come. Okay.
Okay.
So now don't think it's a small table. So this is for example, you will going to apply the same thing into the bigger tables even whenever you need the requirements. Right, create a table name. So this is called as a student number, not null constraint, name and marks. So this is the one. Let's drop this table already existing. So drop table name.
Table name.
So now not null constraint. So this is used to avoid the null values to insert. Okay. So what will happen? This is going to avoiding to insert the null values into the table. So let's so now this is going to drop. Okay, let's create a table. So table got created. Shall I insert the data? Insert
Yes.
into student
Table name.
values. Here student number, right? Suppose 10, name is going to, okay, and then what marks is going to suppose 70. Okay, now we are inserting the data, right?
Okay.
One row is inserted. Now what we are doing, try to inserting one more record. So how we can insert now? We can insert the columns. Here I am going to putting name, comma, marks, right?
Values you have to come, right?
Yeah, it will, no, name, comma, marks.
Oh, columns you're inserting, okay.
Yes, name, comma, marks. Values is going to, so
then you can remove 10
yes,
and put the name and the column.
Okay. So now I try to insert it. Can you read this, madam?
Cannot insert null into apps.student.number.
So you understood, right? So system will not going to allow to insert the null value into the student number level. So it's must and should is required the student number.
What is this apps?
That is instance name. Instance dot table dot column. You can see we are connected apps. So this is while log into the system. Let's show you. See here, what is the username?
Apps.
That is the thing. Apps.
Okay.
Okay, right. So you understood not null. So it is not going to allow you to insert the null values.
Okay.
And it will going to allow the duplicates again. Let's shall I put again one more record here?
Yeah.
So you can.
You already put 70, right?
That
70,
is
70 same duplicate, right?
no. I'm talking about number. Marks you can enter duplicate. So number you should not going to enter duplicate, right? See here it is.
The number. Okay, got it.
Student number. See, same name people will come multiple people. Same marks will come for multiple. Understood?
Student number is unique.
Right. But not null is going to. It is just. It is going to avoiding the null values into the system. That's enough. Understood?
Okay.
You understood, right? What do you mean by not null constraint? This is used to avoid the null values to insert into the system. Okay, keep in mind.
Okay.
Right. So next example is going to same one, but the thing is we are using constraint method. See, even if you are not going to using constraint also, that is fine. But people will going to write it into different styles. So you can see the next one. Create a table name, column number to data type. Constraint keyword they are using. Sir, what is the difference between this example and this example? So both are same, but the difference is you are going to giving the unique name, constraint name you are giving. Understood. So what is that? Constraint, unique constraint name you are giving. Understood?
But you did not put a unique cube, right?
Sorry, name we are giving, not unique. It's not null constraint only. Just we are giving the constraint, not null constraint name we are mentioning there.
Okay,
NN
what
is
is this NN?
right. That is the what. So if you go into properties F4, so there you can see the constraints. What is the constraint name?
Sys underscore not null.
Correct. Not null only. Not null constraint name. What is the name of the not null constraint name? Sys underscore right. Sys underscore C0011091138. That is going to system is going to given the name for this constraint. But suppose you want to give it
Okay,
your
but what is that NN?
try to
alias name?
Manasa, give me a minute, okay? That is the what I am trying to explaining. First, listen and you can ask me, okay? So, in the first example, we are not specified any name for this constraint. So, that is the reason system is going to giving the name, okay? That is called as you are going to seeing the name here. So you can see the sys underscore C0011091138. This is called as a system given name. Okay. The second example, instead of system giving name, you are going to mentioning your own name for this constraint. Okay. Instead of systems given name, you are going to specify your own name here. Now, suppose if you are going to creating your own, so 1 second, table already existed. Okay, so now this table is created. Now you can go this properties. Now go to constraints. So here you can see what is the name NN. How NN is coming? The reason is you are going to give your own name for this constraint.
Okay.
For this not null constraint, you are specified your own name NN. So how you can give it? You should have to mention constraint, name of the constraint.
Okay.
I hope it is clear for you now.
Yes.
So one more time, not null is going to, it is avoiding the null values to insert into the table, and it is allowing to the duplicate values.
Okay.
Clear?
Yeah.
Okay, I'm moving on to the next example, check constraint. Check constraint means, so this is used to insert the values based on the specific condition. Okay, check is going to, it is going to checking the condition. Based on that, it will going to let's go and do some example here. Right. So this is going to column level constraint, column level condition. Okay. So now 1 second, drop table name. So next what we can do here, we can going to see table is created. So what is this? Name, number, marks. Now in the marks level, what I did, I gave the condition. It's not good into 300, right? Marks should be less than or equal to 100. Yes or no?
Yes.
So less than or equal to. Okay. So let's a table created now. Now you can try to insert the data into the table. Okay. So now you can try to insert the data into the table. See what this is?
Check constraint while waited.
Sorry, it's a less than or equal to 1, less than or equal to 100. Oh, sorry, I put it greater than, so we should have to put it to less than or equal to. Sorry, right. See, instead of greater than, you should have to put this. Now you can insert the data. Yes, one row is inserted. Now you can see that record. Okay. Now instead of 70, 170 I'm putting. Is it possible to take?
It will give error.
Right. See now. See the error. Check constraint violated. Understood?
Yes.
So now you understood how to avoid the multiple more than that condition. Based on this condition, data is going to insert. See, sometimes you can see into this. We are seen when we are going to studying at that time. Some people got 900 marks out of 100. That means maybe it is 90 or something. They by mistakenly they are going to enter.
Okay.
Right. So now the same again. You can going to give it your own name also. Constraint name you can give. So now coming into table level. So this is called as a table level constraint. Same example, same functionality. The difference is the previous one we are giving into column level. This is going to table level. So you can observe the table level and column level. What is the difference? So here what will happen? Check we are using first, and after that we are putting condition. See, column data type, size, check and condition. If you coming into table level, check, column data type, comma. So try to see here, comma. After that condition we are adding here.
Okay.
You got me? Difference you observed, right?
Yeah.
Okay, so this is the table level, same functionality. So now if you can go into alter also you can do, madam.
Column table level condition only will be not null. We cannot use check. I mean, you only showed check. We cannot use not null.
No, we can't.
So you mean table
that
level?
is table level null we can't use. The reason is let's I think only one point I missed it here. 1 second, give me a second. Sure. Right. Hello.
Yes, sir.
See, check we can do it all the levels: table level, alter level, column level. Okay. But not null we can't do for all the levels. Only column level. See, we can add this constraint only column level. Clear?
Yeah.
So now if you go into alter level, this is same. Alter also you can use. Suppose already you created a table madam, so you want to add some condition. Using this alter, you can do that condition. Clear?
So same thing?
No, madam. See, this table already you created. Okay, you done some data also inserted. Again, you feel it as a you want to add some condition. You can going to add that same condition using the alter keyword.
Okay.
So normally, last time what we done, if you already created a table, if you want to add any specific columns, you can use the alter keyword.
So alter is also applicable. Check. Only check.
Only check.
Okay.
Okay, right.
So if you want to write the check, can you just go back to that screen, sir, once?
Check you can write it. That also you can do again.
Yeah, check, but the syntax here is how. If you want to write marks, for the same example we can write, right?
Same, and then you can see add check constraint, right? Add check constraint name.
Okay.
Constraint.
Constraint name.
1 second. Constraint name of the constraint. What is the condition? Marks condition. You can give like that.
Okay.
Clear? So you can see all the already same example is there.
Okay.
Okay. So this is the one. So you can see that. See, add constraint name. Check. Sorry, reverse I put it. You can going to put it this. Not like this. 1 second. Before of the add, you can going to put it. There. Add constraint name check. Like this you can do.
Okay.
Okay. All right. So moving on to the next one. So column level, same things you can going to do. Table levels, unique queue. Again, unique queue is nothing but it is going to so try to avoid the duplicate values. But not null is going to it will going to allow the it will not avoid the null values, but it will allow the duplicate values. Understood?
Okay. Yeah.
Unique queue is going to this is used to avoid the duplicate values. Okay, but it allows the null values.
Okay.
Understood? So I am just again I am trying to explaining the same thing. What is the use of not null and unique queue? Not null is going to it is avoid the null values into the system. Okay. And the unique queue is going to it is avoid the duplicate values into the system, but it allows the null values.
Okay.
So we can add this constraint in all the levels. Okay. So you can going to let's create this table and so now you can going to see now create table name unique queue, just unique queue keyword you can use.
Okay.
Okay, table is created. Now you can going to insert the data into the table. Okay, just I inserted one record. I try to insert one more record. See what will happen.
Unique constraint. So you cannot have the same
number. Same number it is. If I put null,
it will allow.
Yes, it will allow. Null. But not null will going to allow the nulls?
No.
Okay. But it will allow the duplicate values. Okay. Right. So clear? See, null is coming. It's allowing. But duplicate is not allowing. So this is called as a unique queue. Unique queue keyword. You can add it into alter also. You can add it into table level also. Both the levels, 3 levels you can do this.
Okay.
So while going to using alter, one more action you need to take care of your end. So that is called as suppose already table is created, madam. Okay. Now you can't give it this unique queue number. Already duplicates are there in the system. Understood what I said? See, you already created a table, already you inserted a duplicate data in the table. You can't add the unique queue constraint on that table with before going
if
to
you
remove.
have already duplicate values, you mean?
What do you mean by alter statement? So when we are going to performing this, when it is required this concept, alter is required always once you created a table and you inserted a data and you feel it as a you want to add any constraints. So you will go for the alter, right? Yes or no?
Yes.
So now in this table data already it is inserted duplicate data. Now suppose now I want to add a marks unique keyword. Is it possible? Marks.
No, because already you have your
Say this.
Duplicate value.
Read it. Clear now?
Yeah.
So now how you will going to add now? You should have to remove the duplicates, then only it is possible. Clear? Okay. So keep in mind that is. So moving on to the next one. So primary keyword. So primary is going to the one of the most important one. So primary is nothing but a not null plus unique. Not null plus unique. So this is used to avoid the duplicate and null values. So that means once you add the primary key, it is not allowed to insert the duplicate values as well as null values.
Okay.
This will work as a combination of the unique key or not null. Okay, primary key always attached to the parent tables, and we can add this constraint all three levels. Okay.
Parent table. Okay.
Let's show you the example. So you are following, right?
Yes.
Okay. So now you can see. So now I try to create a table, the number column primary key. That's simply primary key. Yeah, table is created. Now you can going to insert the data into the tables. Okay. So now I try to insert the data. See, cannot insert null into the table. Understood?
Okay.
So 10 now. Again, cannot insert the unique constraint is violated. Understood? So this is so it will not going to allow the duplicate values and as well as
Not null.
null values also. So always it should going to take the unique numbers here.
Okay.
Clear? Primary key. Primary key is going to, you can add it as a one primary key column in the table.
Okay.
Any table, one column is required for the primary key. Keep on mind that is. Suppose you are going to creating 10 tables. So the 10 tables, each and every table is required. At least one primary key column is required. One unique column. You got me right?
Yes.
Okay, fine. So now this primary key column you can apply into the table level also. Table level means so the end of the table you can going to put it a primary key name of the column. Okay. So alter level also you can do. Alter table name, add primary key number, name of the column. Okay. Now moving on to the foreign key. Foreign key means so this is going to say parent and child. Parent and child means how the relationship is coming. Suppose parent is having and childs are there. Now parent is nothing but suppose the department is the parent, employees are the childs. In the employee and department, you are going to giving your own. See, I will going to show you here. See, I have a department table. Okay. So department table, what I have, department number I have, and department name, right? Right. Now, if I go to employees table, it should be required the foreign key as a department number. See now. In department level, department number is a primary key column. In employees level, department number as a foreign key now. This is called as a foreign key. Understood? Now, how would you going to divide department-wise employees based on the department number? Got it?
Can you repeat this once again?
Now, simple logic, madam. See, whenever the requirement is coming, something branch and students. Branch is a one table, students is a one table. Now, branch table you created. Name of the branch ID, branch name, and creation date and a branch location, something you are putting. The table is created. Okay. In their branch ID is called as a primary key column, right?
Yeah.
And now you are going to creating the student table, right?
Okay.
In the students table, student ID is nothing but a primary key column.
Okay.
Now in that students, how did you going to find it that particular student is belonging to which branch?
Using branch ID.
Right. So already in the branch table level, branch ID is a primary column. Student level, student ID is a primary column. So if you
Okay.
are going to putting branch ID in the student table, branch ID is nothing but a foreign key relationship.
Okay, I got it now.
Clear? So,
Yeah.
so like that we have to put primary and parent key relationship. Now in the students table level, branch ID is it unique or it is going to duplicate? I'm repeating question. Okay. So
Yeah.
branch table level branch ID is called ID is a primary key column. Student level student ID is a primary key column, and student level branch ID is going to, is it unique is required?
In students table?
Yes, branch one.
No, it will not be a.
Right. So that means parent key is always going to, it's a duplicate and duplicate.
Yeah.
Clear?
Uh-huh.
Clear, right? Okay. Let me show you some example. So this is used to reference the parent table primary column, which allows the duplicates. Parent key always attached to the child table. Understood?
Mm-hmm.
So this is always going to child table only. Okay. And we can add this constraint table and alter level only. You cannot add the column level. Okay. Let's try to do this now. Okay. Right now, I'm going to creating a tables now. Okay.
Mm-hmm.
So now I'm trying to creating now without. Is it possible to create now? See, you can't create it like this. First, you need to create a parent one. Understood, right?
Mm-hmm.
So first to create a parent. 1 second. Let me show you that example clearly. Tabular view does not exist. Correct. So first you need to create a create a table. Create a table name. Table name is going to dept underscore. Yes. As cell star from 1 second. So that's fine. You can going to create table name values. What are the things you want? DBT number, right?
Yeah.
DBT number. DBT number is going to, it's a number and primary key column.
Mm-hmm.
Yes or no?
Yes.
Primary key column, comma, DBT,
Name.
dname is a varchar to of some size. So you can put it to dname and then location. Varchar to of 50. So clear now?
Yeah.
So now this table you are going to creating. So missing value, create table name, values. Correct only, right?
Mm-hmm.
What it is missing? Primary key. Sorry. Create table. Oh, sorry, values is not required, right? Yes, table created. Okay. Now department number is primary key column in DEPTSS underscore table. Now I am trying to creating the employee table. Employee number, employee name, department number. So department number is going to just number. I don't want to give the this, and the primary key is In employee table level, primary key is EMP number. Understand?
Okay.
Now foreign key is going to department number, DEPT number, to references to this one. References to department number.
What is department SS references? That is a table name.
That
department
is
number. Okay.
Parent table name. So
You already wrote this, right? Foreign
wait.
key, department number. Again, you have to write reference.
No, wait. Up to this is going to employee table 1. Okay. Now the foreign key, foreign key is nothing but a department number in employee table. So with the reference of this table, parent table, references to department, DEPT underscore SS of DEPT number. Got it now?
So this foreign key department number comes to the EMP underscore SS.
See, this table, both the departments numbers, I am going to giving the relationship, foreign key relationship. Let's do this table created. Let's we'll going to insert the data. You will understand. Okay.
Okay.
Right.
The down part I understood. Here I'm getting confused.
Right. So now insert. Tell me, madam. Insert into table name. EMP underscore SS.
Values.
Values. Right. EMP number. So
1, 2.
Okay.
Name you can put.
Okay.
Then you can department number 2, 3.
2, 3. Done na?
Yeah.
Can you see now?
Yeah.
What is the error?
Integrity constraint. Validated parent key not found.
Correct, madam. Parent key is the departments. So departments, we didn't enter any data into the departments.
Okay.
So this is going to violated. Parent key department number references to department underscore SS, so department number. That is going to causing the issue. Understood?
First, then we have to insert into department.
Correct, right? Without parent, how the sales will come?
Yeah.
You got me now?
Yes.
So now insert the data into
DP underscore SS.
Okay.
Insert DP underscore SS value.
Okay.
Department number 1.
1 or 1, 2?
1, 2.
What is the department number you are entered in the top? 2, 3. Sorry, 1, 2. 1, 2 is the department number.
No, that is employee number.
Okay. What is the department number? 2, 3, right?
2, 3.
Right, 2, 3. And department name. Suppose IT.
IT. Location.
Yeah, you can give it anything.
India.
BLR. Okay. Values.
Select keyword.
1 second. Insert into DEPT SS underscore values.
Value spelling wrong.
Okay. Right, table is inserted. Now you can insert into the employees table. Both are inserted now. Got it now? So now without data into in a department, you can't insert into the employees. Clear?
Okay.
This is called as a parent key relationship.
Okay.
So alter also you can do, and you can going to play that. So now using on delete cascade, can you read it, madam?
By using this clause, you can remove the parent record even its child exists. Because whenever you remove the parent record, Oracle automatically removes its dependent records from the child table. If this clause is present while creating foreign key constraint.
So what you understood?
He's saying you can remove the parent record, even child exists.
Right
If you
now,
write this
one
clause
second.
in your table.
Now, what I will going to do now? Shall I going to remove the record in the employee table? Okay. So shall I remove now? So now suppose. So now employee level 2 records are there, right? So shall I remove the record? Delete emp underscore ss where emp number equal to 1
12.
1 1 2. So record deleted, right? So I don't want 1 second. I don't want to delete. Roll back. So now shall I delete the department record?
Yes.
Okay. So 1 second. So delete dept underscore. Not going to. You can't delete directly the records. 1 second. No, foreign key and primary key, these relationships are there. You can't delete directly record into the parent without child without deleting the parent. Understood?
No, I did not understand.
No, madam. See, EMP table, department table is there. Now, suppose you try to removing the employees. Okay, you can remove it.
Which one I'm trying to remove? EMP or DEP?
EMP you can remove. Department you can't remove.
Okay.
Because see you can take it any example of already department is there, employees are there. Without going to firing all the employees, are you going to delete the department itself?
No.
First you need to remove all the employees, then only you can be going to remove the department table.
Yes.
Okay, so that is the what. So that means without going to deleting the child records, you can't delete the parent record. So that is the meaning of that. So you can going to create a table using that cascades. You can see now. So now references DBT number. This same already you are seen up to. Okay, only one more keyword we are using on delete cascade.
Okay.
So this on delete cascade means already you are seen and understood this, right? See, by using this cause, you can remove the parent records, even child records exits. This keyword, suppose if you are using this keyword, you no need to delete the child records. Directly you can going to delete the parent record. Okay, right? So that is the one. So this you can going to use it into alter level also.
Okay.
Right. Moving on to the composite keys. Composite keys is nothing but you can going to add multiple things into the see, suppose unique key or a primary key or foreign key or single column you done, right? So you can add it into multiple columns at a time. See, unique key for your student name and student number. Both I am going to using unique key. So two columns I applied unique key constraint at the same time. So that is called as a foreign key relation. This is called as a composite. Give me a second. Mansa, give me a minute.
Yeah.
Yeah, look at these ones.
Okay.
See, suppose now you have, so just I'm going to asking you to create a some course table, student table, category table, okay, 3 tables I'm asking. So now you are going to creating, suppose see, so you are going to creating a course table. So what means course means what are the courses it is available, okay. Next, student table. The student table, how many students are there in that, okay. And then instructors table, that means trainers tables, what are the trainers is available. And the category table, what are the category it is going to happening. Now for each course table, course id, student table, student id, trainers table, trainer id, category level, category ids is coming. Those ids you will not going to insert into the tables. First of all, keep on mind, okay. Those ids should be going to coming from the sequence only. Clear?
Mm-hmm.
Understand now? Only this
Yes.
much. See, whenever you are going to using id, that id means don't give the option to insert that id into the table.
Okay.
Okay, understood? Why sir, why can't you insert into the id table? Okay, perfect. So in the form, suppose in any front end form, id it is going to there. Are you going to, how would you know which id you want to enter? First of all, you don't know, right? So that IDs should be going to generated to through the backend. Okay. Let me categorize some, show it some table. So PO headers all. So some table in the Oracle this is, okay. So here ID is there, PO header ID. This is going to auto generated one. No one will going to enter manually. Sir, how it is automatically generated means using the sequence. You can see it can be used automatically generate primary key and unique key values. So automatically generated means what will happen? You can avoid the null values. You can avoid the duplicate values. The reason is sequence is always going to generating the proper sequence numbers. And now suppose invoice numbers. See, now suppose invoice number 10 is generated today. Tomorrow one more invoice you are generated. It should not going to take 10, right?
It will take 11.
Right. That also you can use the sequence. Okay. A sequence can be either in ascending order or a descending order. However you want, you can take it. And you can going to decide the sequence should be going to starting with 100 or starting with 1000 or starting with 1 lakh. However you want, you can going to take that also. And one more thing, in the sequences, you will going to put the maximum value or hello. Right. Hello.
Hello?
Yeah, yeah. Here is some power issue, power problem. Okay. So let's. So now, so we are going to talking about sequence, right? So the sequence, first of all, sequence is a database object and it is used to generate the unique values. Okay. And then sequence can be automatically generate all the values and it is going to avoid the duplicate and null values. And a sequence can be either in the ascending order and descending order. You can going to use it. Okay. So the sequence you can going to put it either you can going to start it your sequence 100 or you can going to start it as 1,000 or it is a 1 lakh. Where you want to start, you can going to start it your sequence. Let's see some syntax example and then we'll going to understand more. So this is called as a sequence syntax. So keep on mind syntax. So you will going to understand. So here is the sequence syntax. So create sequence name and increased by n and start with n. Okay, and the minimum value is n. So and cycle is going to, you can give it as a cycle. Can you give me a minute? I'm connecting to different network. This is a little bit slow.
Okay.
Right. So now you can going to see now. So you are able to see my screen, right?
Yes.
Okay. Right. This is called as a sequence syntax. So create sequence, name of the sequence increased by n and start with n. Maximum value also n. You can going to put maximum value whatever you want, and then minimum value n. So cache no cycle or no cycle, and then cache or no cache. Sir, what do you mean by increased by n? Okay, let me take one example and we're going to see. So you have a table, right? So student table. So we removed. One more table you created, right? What is the table?
Employees.
Okay, employees. Okay, right. In this table, employee number, suppose I want to make it as a sequence. Okay,
Huh?
you got me right? What I want to do? I want to make it as a employee number as a sequence. Okay, so now you can going to use it. Create sequence. Sequence name is employee underscore number, employee number sequence. CQ. Okay. Now increment by 1. Okay. Increment by 1. Okay. And then start with suppose start with 1010. Okay. Maximum value. Max value, suppose I want only 1 lakh. Okay, 1 lakh. Minimum value also you can take. Minimum value is where you are going to start at that only, right?
Mm-hmm.
Minimum value is going to suppose 1010. Okay, cycle, and then no cache. This is the one you can going to create a sequence now. Sir, how it is going to working this, sir? See, sequence created. Down you can see sequence created. This is the name of the sequence is going to incremented by 1. Incremented by 1 means starting ID it is going to taking 1010. So what is how many numbers it is going to incremented? Only 1. Record to record it is going to incremented by 1011, 1012, 1013, like that it is going to incremented. The reason is you are giving incremented by 1. Understood? Okay. Hello.
Yes.
So now maximum value is going to how many I am giving? Only 1 lakh, right? So once 1 lakh is going to 1 lakh employee number is coming, then it will going to cycling. Cycling means it is going to starting again 1010. If you are putting no cycle, then it is going to stopping once the maximum value is reached. If you are putting cycle, then automatically it is going to stopping that. Cache means it's going to storing into the buffer level. So it is going to allocating this memory into the database level. Cache, no cache, you can going to use it. Got it now? So any question?
Yes.
Up to?
No.
Okay. Now how to use this sequence? Yes or no? You should have, now you created a sequence simply. But how to use this, right? Truncate table name. So simply just I truncated, that means I removed the data. Okay, now table is truncated. You can going to check the data in the table. There is no data. Now you can going to insert the data into the table. Insert into table name. Okay, and then you can going to take it as a employee number, whatever the values you want. Employee number, comma, e-name, comma, department, and join date. So these are enough. Okay, so now you can going to put the values. Values what we need to put now. Employee number, are you going to putting the manual 1 2 3 4 like that? No,
We're going to use sequence.
Right, emp number underscore sequence. You can going to use that. This is dot current value, dot next value or current value, whatever it is. Next val. Okay, next val, comma, e-name. E-name you should have to give it as a, and then department is going to, you should have to give it, and join date is this date I'm going to put in. Shall I insert the data now? What is that e-name? So e-name or e underscore name? E underscore name, sorry. Okay, emp underscore name, e-name, employee number. So employee number is what? emp underscore number. Okay, so now one row is inserted, madam. Shall we see the data now?
Yes.
Okay. See how this 1010 is coming. So now I'm going to changing name here. Okay. Now I try to insert the data again now. Okay, one more record is inserted. Can you check the data now?
Yes.
How 1011 is coming? See? Are you able to see the output data?
Yes.
So now you understand how the sequence is going to working?
Yes.
Okay, so how you are using the sequence also you are clear. Okay, how you are going to using means you should have to use into insert statement level. Okay, so this is the way you can going to use your sequences. Okay, now create sequence name, and then create sequence incremented by, you can using the sequences into different styles. Initially current value is not defined, next value is going to starting with as a current value. Okay, after that next value, current value is always equal. Okay, so this is the way it is going to starting. So always this if you can going to change it, one more thing. See, suppose now here we are going to using, right? If you are not going to using anything incremented by 1 or whatever it is, one more sequence. Let's create the one more sequence. Okay. Create sequence. Just okay. emp number underscore sequence. Yes. Okay. So now I'm going to create a query. I didn't use anything created by, increased by, or start with maximum value, minimum value, hashi. I didn't use anything here. Simply just create sequence name. So now see F4. Can you see now? What will happen if you are not taking anything? Hello?
Yeah, that's what I'm thinking. What will happen if you don't take anything?
Yeah, what happened? Now you can see the structure there. By default, automatically it is taking increment value as a 1. Okay. And the maximum value is going to taking a Oracle provided one. This is all lines. Understood? Minimum value
Yes.
is 1, incremented by 1, and the maximum value is going to all 9s, and the cycle is no, order is no. Cache size is going to defaultly selected as a 20. Now, if you go into whatever you created manually, that means emp number underscore sequence. Okay. Okay. So this is the one, whatever you are going to see. Okay. Got it right? Now you compared both the things, right?
Yes.
Okay, right. So now you are clear these sequences. So you can going to use it to n number of sequences and wherever you want. Okay. So now moving on to the next one. So altering sequences also you can do, madam. So they alter the sequence. Maybe suppose you want to change the starting value, or you want to change the increment value, or you want to change the cache value. You can do the alter. Okay.
Okay.
Now increment value 1 we are putting. Suppose you can change it to 2 also. See, suppose alter sequence name. Okay. Incremented by 2. What will happen now?
Only the structure will change.
The inserting sequence is going to change. Alter sequence name incremented by increment by 2. So what will happen now? If I did yes, altered. Shall I insert one more record here?
Yes.
Now what is the value it will come?
2, 4.
Right. Now you can see implies 3 only coming. Okay. So 1 second. Later we'll going to insert one more. Now we can see. See now 13 to 15. Understood?
Yes.
Okay. Like that you can going to do the alter. So this is the way it is going to working the sequence. So moving on to the next concepts. So sequences are over. Okay. So already giants we done. Next, excuse me. Right. Next, we will going to see the set operators. now you can going to see the set operators. See, set operators is nothing but, so whenever you are going to picking the different data, you want to combine the data. See, suppose you have a group of items, so now you want to club that group. How we can do that? Right? You can going to use the union condition. See, suppose now I have the same structure of employees and again the same structure of different set of employees. Two different set of employees with the same structure. Now I want to bring into under one umbrella. How we can do that?
Union.
Yes, you can going to union. So now union means what? Whatever the same numbers in the set 1, whatever the same numbers in set 2, equal, both the equal things only, it will come under union. Understood? Union all means whatever. Let's explain you clearly. Okay, so now I have a set 1. Okay, so now set 1 comma 2 comma 3 comma 4 and 8 7. Okay, so now set 2 set 2 set 2 you have, suppose now you can come 2 comma 3 comma 5 comma 7 comma 9. Now like this it is there. Okay, now set 1 union set 2, what will come, madam?
We'll get 2, 3,
1 second.
7.
2
2, 3, and 7.
2 3. Okay, 2 3 and 7, right? So this is called as a union. So I hope you understand clearly. Union all.
Yes. Everything should come.
Union all set 2. Everything it should come.
So 1, 2, 3,
1
4,
comma
5, 7, 9.
1 2 3 4 5 7 9. 7 7 and 9. Okay. So and intersect. So union we done,
Yes.
union all will done, intersect. Okay, sorry. Intersect means set 1 intersect set 2. What will happen?
Common records is written.
Right, perfect. Yes, tell me.
So 2, 3, 7.
Intersect means only the common records. Okay, so wherever.
Then what is the difference between union and intersect?
1 second, 1 second. I will tell you. Intersect means only one it will come. Okay, wherever it is going to intersecting that records only it will come. Let me. I will going to help explain you clearly. Okay.
Okay.
So 1 second. Only set A records only it will come. A minus B. 1 second. Let me see this. So 1 second. This will give you the common records, multiple tables having the same structure. Okay, this will combine the records, multiple tables having the same structure. Okay, so common records between the both the tables, and this is going to combine the records of multiple tables having the same structure. Union and union all. Right. So here union level it will come the common records with distant records. Duplicate will not come. Okay. Intersect level it will come this. Okay, we'll see the example. Okay, A minus B. Set A minus set 1 minus B. Set 2 minus. So what will happen now? Hello.
That's what I'm looking. -2B.
That means only A records will come. That means set 1 records only will come.
1, 2, 3, 4, 7.
Correct. Okay. So let's see examples. You will going to understand clearly. So now before going to using the set operators, the table structure should be same into the both the queries. Understood?
Okay.
Structure should be same. Otherwise it will not going to help. So now what we can do, you can going to create a 2 tables. Okay. Now table 1 and table 2, yes, can you try to create into the same structure with 2 tables? Okay, you can try to join that. Okay, 1 second. Create table, create table name, employees.
But the name should be different, right? If you put the same name, it will not allow you to create, right?
Right? No, name should be different. Structure I'm saying.
Okay.
As keyword we should have. So you can now table created, right? So now select star from employees, union, select star from XXGLT employees. Sir, if it is everything same, why you want this? See now, only 4 records are coming, right? But this is, we are going to, in the real time case, we are using into different style. I will tell you that also. Okay, first you should understand the basic thing here. Okay, I will tell you in real time case. Now see, 8 records is coming. Understood? Union is coming only 4 records. Okay, union all is coming 8 records. Okay, so now it is going to intersect. With that intersect you can going to use, and we'll see how it will going to help me. Okay, only 4 records. The difference between intersect and union, we need to understand clear. Intersect is nothing but it is going to subtracting the second table and it is giving into first table. So wherever it is intersecting, let's see, and then minus you can do. Only first table records will come. We'll insert one more record into the second table, then we'll going to see the more in detail example. Minus. Okay. So nothing is coming. Minus means, say both the records are common, it is going to subtracting, nothing will come, right?
Yes.
Now what we can do, you can going to insert one record here. Okay. Now I'm going to inserting one more record here, KK. Okay. Now record is inserted. Now union I tried. So total 5 records are coming. See? Hello? So total 5 records it is coming. Okay, union. Union all is total 9 records is coming. Intersect is going to 4 records only coming. See, that means intersect is nothing but a common records between both the tables.
Table.
Union means the distant records between the both the tables. Understood?
Yeah.
Okay, now you understood, right? Intersect and union.
Yes.
Okay, now minus you can see only 1 record you got. Why?
Because you're minusing the table 1 from table 1 to table 2.
Right. So these are the things. So you can try to practice it, these things. Okay. So I will going to help you in more into these operations using different examples.
Okay.
Okay. So next class, tomorrow class, we'll going to see into the indexes, partitions. Okay.
Okay.
See, deferable constraints. Deferable constraints means deferable initially immediate, deferable initially deferred. So this is also one type of constraint. So this is what it is going to do. It's going to check before insert and before going to commit. Whenever you are going to inserting the records into the table, at that time, this constraint is going to working. So sometimes deferred and immediate. Immediate means whenever you are going to inserting the data into the table, immediately this constraint is going to fire. Understood?
Okay.
Suppose now you are going to adding this deferred initially immediate, this constraint. So what will happen, madam? So whenever you are going to inserting the data into the table, immediately this this is going to fire the trigger, like this constraint will fire. Now initially deferred initially deferred. So this is it will going to allow to insert the records into the table. Okay, there is no issue. Whenever you make the commit, so once you put the commit, automatically this constraint will going to fire. So you understood?
Yes.
Okay. So how we will going to do that? We can going to create the same thing. Say unique constraint. You can going to use it unique constraint or not null or primary key or foreign key, whatever it is, for for these two constraints. Understood?
Mm-hmm.
You can use it any constraint, but the constraint firing time you will going to decide using these two things. Got me?
Yes.
Okay, fine. Next, so these are also it's very important concepts: enable, disable, enforce, and drop. These are the possible operations using the constraints. So you can going to your constraints, you can enable it, or you can disable it, or you can drop it, or you can enforce it. So enable means suppose no, you are going to apply the not null constraint. Okay, that is already disabled. You can going to enable that constraint. Understood? Suppose some constraints are there, you want to stop that constraint working, so you can stop it. 1 second, we'll show you one example. See, you can going to see this. Now we have a table student, right?
Yes.
So this is the data it is available. So what are the constraints are there? So you can going to see the constraint. Here we can see the constraints. Only one constraint it is there, primary key constraint. Okay.
Okay.
Here you can see. Now what we can do, alter table name, enable constraint un. Enable constraint un means this is the constraint name of the constraint.
Okay.
So what is our constraint name? You can going to put it into our constraint name here. Enable, disable. It's already enabled only. You can going to disable, then you will going to see that one. Okay, anyhow, let's see. Okay. Sys underscore 300 11 09 146. Okay, so this is our constraint. So you can going to do this. It's see table altered. Table altered means whenever you are going to try to inserting the data. So let's take that example one. Okay, I will try to insert the data into the table. Let's see. Now you can take it into disable one also. This will going to disable your constraint.
But you put enable, right?
Yeah, both will show you. Give me a second. Enable, disable, both.
Already enabled is there in the table, right?
Correct, madam. That is the reason. First, I will going to disable, then enable. I will do. Okay.
Okay.
So now.
So generally, all the constraints will be defaultly enabled.
Yes, yes. Once you're done, that is enable only, right? Until you are disabled.
Okay. So when you create the constraint, it becomes defaultly enabled.
Yes.
Okay.
So now marks student number 13. Okay. And name is going to quotes. So and then you can give it as some marks 120. So now you can going to insert this record. See, record is inserted. Now record is inserted. When I try to insert same record again. Okay, so error is coming. That means primary key constraint is violated. Right? Now I try to disable this constraint. What is the constraint name?
SYS underscore C.
Constraint means primary key constraint. Keep on mind. Right. Now it is disabled. Is it possible to insert the data? Yes. See? How many rows are inserted? Duplicate. You can say 13. How many it is there? 13. Now I try to enable it. Is it possible to enable?
Yes.
No, you can't.
You disabled it. Again, you're enabling it, right?
Yes, I try to enabling again, but it is not enabling. Reason?
Because primary key violated, because you have n number of times primary key in that.
Duplicate is there.
Duplicate keys are there.
Yes. So you should have to delete this data and you can
remove them.
Right.
And
Enable
then
it.
enable them.
Right. You got it. Delete student. So where name equal to. Right. 4 rows are deleted. So you can going to commit. Now you can enable it. Okay. Shall I enable now?
Yes.
Okay. First I will try to insert this record. One record. Okay. So one record is inserted. So total 3 records. Now I try to enabling. Okay. Now table is altered. So now shall I try to insert? Yeah, it is not inserting. So I hope you understand constraints enabling and disabling.
Yes.
So you no need to remove madam. Keep on mind. So suppose someone is coming, can you please try to stop that constraints? So you no need to remove the constraints. So simply you can disable it.
Okay.
So if you disable in future, if it is required again, you can enable it again, right?
Yes.
So you can do that. So this is the use of the constraints enabling and disabling.
Okay.
So now you can go into next enforce. Enforce means this is going to future updates. Suppose in future if you want to do something, okay. So at that time it will going to help. This will enforce the constraint rather than enable for future inserts or updates. This will not check for the existing data while enforcing the data. So understood, right?
Yes.
So this is suppose whatever the current data it is there, it will not going to, it's no issues. In future you are going to doing at that time it is going to violated again.
Okay.
So now we are deleted, right? You no need to delete the data. So you can going to enforce it now. And future data it is going to violated.
Okay.
Right. Drop means you can drop the constraints simply. Suppose specific constraint you no longer is going to using, you can going to drop it. Clear?
Yes.
Okay. Right. Case and the default. Right. This is called as a one of the cases. This case is like a decode function, madam. Okay.
Okay.
We done decode, right? How we done decode and the similar kind of case. But they case and decode is a decode. You can't use the conditions, and in case level you can use the conditions.
Okay.
Let's show you the difference. So constants is over now,
Okay.
right? So now see, this is going to salary. This is column. Now case column name, when condition, then result, when condition, then result, else result, and end case. This is the EMP table one. So now the same one you can do it into using decode also. Did you remember? Same.
Decode.
Yes, using decode you can going to do same thing. Shall decode of, what is the one? Shall
Shall.
comma shall comma 500, right?
Yes. Then low.
Right.
Else.
500 or 5,000, whatever it is. Okay. Then you can going to put low. Okay. Comma again
Else.
5,000. Whatever it is. See how you want. You can going to
High.
put it high. Then you can going to put it into high. Comma medium.
Medium.
So same way it is going to working the case also. Clear for you?
Yes.
So you can going to put it into alias for this.
Okay.
Shall range. What is this? Decode of, okay, here, comma you need to put. Right? Same again, you will going to apply here also. Now, sir, both are similar kind of functions. Why you want two functions? Here, you can going to use it condition, madam. Okay.
Okay.
Less than. Here, you will, whatever the shall we are going to using here, right? You can remove the shall there. Oh, sorry. I will going to write a new function. See, the same you can take. Okay. You can going to put it the conditions into case. See now, you can going to put above salary more than salary greater than 500. Okay, suppose 5,000 I will going to put, depends on our work, I will going to show. Salary less than
5,000.
50,000 we can put. Understood now?
Yes.
Okay, missing keyword. Yes, this is not required. Here column name you can remove. Reason is you compared in the conditions level. See
Understood.
now. See? So this less than greater than the comparison, you should not going to do it into the decode level. You
Okay.
can't do that. So the case you understood, right? So two things
Yes.
you done case. Case using column you are going to taking, directly you are going to checking the conditions. You are removing the column there, and with the column data, you are going to checking the conditions here. I mean comparison operators you are going to using.
Okay.
Clear? Okay, right. So moving on to the next one. So keep in mind this is the default. Okay. So we'll come back to the default and abstract data types. So now constraints we finished. Now we are moving into joins. Okay. So joins is very important concept. If you go anywhere, so if you are going to doing coding, joins are majorly going to working. Now tell me, madam, when join is going to required?
When two or more tables together, you have to get the results, you use joins.
Absolutely correct. Whenever you have more than a table, so you need the join condition, right? So now join, so what is the purpose of the join? To combine the data across the tables. So now you have the data in two tables. So you want to pick the some common data between both the tables. So at that time you will going to join the tables. So that is the meaning of this. The purpose of the join to combine the data across the tables. A join is actually performed by where clause. Where we are going to writing join conditions in select statement level, where
Where
clause,
clause.
under where clause combines the specified rows of the tables. Okay. If the join involves more than two tables, then Oracle joins first two tables based on the joins condition, then compares the results in the next table shown. Right. So if you are going to joining with the two tables, first Oracle what it is doing, and it is going to comparing both the tables data. Whenever it is matching, the data is going to picking up. So here we have some different type of joins: equi-join, non-equi-join, self-join, natural join, cross-join, outer joins, and inner joins, on-class joins. So just they are going to dividing like this, but only the one thing join conditions means how you are going to doing your join conditions. I mean how you are finding your joins between both the tables. Okay, how you are using outer joins and self joins and equi joins. These are very important. Okay. What is the difference between equi-join and non-equi-join means? Whenever you are using the equal condition, it is called as a equi-join. Understood. Suppose now I try to join some record here. Select star from EMP. Okay. Where DPT department number equal to 10. What is this join, madam? Equi-join or non-equi-join? Equi-join. Okay, it's equal condition. Compare with equal condition, it's a equijoin. And then now shall less than 60,000. What is this one? Non-equijoin.
Because you don't have equal sign?
Yes, correct.
Okay.
Other than equal sign, all are going to non-equijoins. You can going to put it and See, and commission is null. Is condition also it is going to, and commission is null. Understood? So whenever you are used equal condition, it's a equigiant. Whenever you, other than all the giants, it should be into non-equigiant.
But we are not writing any join, right? We are just writing conditions.
You say,
and we are taking only one table.
Conditions only, we'll call it as a giants. See, madam, join means, so you are going to joining with this column and we are comparing with this. So whenever you are going to putting one more table now, okay? Now suppose DEPT D. Now you are feeling you are going to doing joins. E dot
Yes.
DEPT number and D dot DEPT number. Yeah, you
Yes.
can do it. You can do it. E dot E name. E name. D dot D name. Okay. Cool.
Yes. No, not properly.
Comma.
Okay.
So D dot.
Defined. D
Okay.
dot.
So now this is called as a giants and non-equigiants. So now let's go into, say, you understand equigiant, non-equigiant, right?
Yes.
So whatever you can do, equal condition. See, giant which contains the equal operator is called as a equigiant. Okay, using class during this time, so no one is using, madam. Okay, don't focus on this first of all. Unnecessarily, it is waste of time to you and confusion.
Okay.
Okay, same thing they will going to do. Just simply they are going to using the using class. But 99.9% no one is using this using class, okay, and on class and all nowadays. If you want practice, you
Okay.
can practice it, no issues. But most of the cases nowadays, no one will going to using. Non-equigiant means say a join which contains an operator other than equal condition. Okay. So self join. Self join is very very important. Okay. Now you can try to see query to get employee and his supervisors and his managers. Okay, how we will get, madam? You can see now employees table and help me how we will get employee and his manager.
Employer, you select E dot employee.
Sorry, employee select what, where is coming E dot?
Alias name you don't want to put?
Okay, now I am going to taking alias E. Okay.
Okay. Comma.
See, where is manager first of all here?
Here it is there. Next to job, you have a manager.
That is a manager number, but there is no name, manager name. Now you will going to see for clerk manager is 7839. What is the, but there is no manager name, right? How you will going to get manager name? What do you mean by self join?
Joining the same table 2 times.
Right, perfect. But when it is comes into that requirement, which situation you are going to joining same table in 2 times?
When you have the manager and employees, both the data in the same table, you use it.
Right, correct. So how we will going to do now? Okay, see now. I try to display the name, e-name, okay, employee name.
Okay.
So now I displayed the e-name. So invalid table name. Okay, fine. Right, e-name is coming.
Okay.
And I displayed the employee number also. EMP number. Okay.
Mm-hmm.
And MGR. MGR means manager number. Okay. Up to there is no issue. It's clear, right? Now manager name. See who is 7839. 7839 means who? King.
King.
For Blake's manager is King.
Okay.
For
So class manage Blake.
clerk manager also going to King only. 7839. Jones manager also King only. Okay. So
then Scott manager is Jones.
right.
Okay.
So now EMP same table I took it and I took different alias for the table. M dot ename. Now we need to join the condition, right? Where E dot EMP number comma EMP number equal to M dot MGR. Now you can going to M dot EMP name. EMP number. And let's try now.
For manager you did not give.
Yeah, one second.
And E name you did not give.
Yeah, we'll give. Sorry, E name only we can take. EMP.
Here also you did not give E name. E dot EA.
Okay. Now, who is the John's manager? Code only.
7839 is John's manager. You have to go up and see who's this 7839. King.
It's not coming properly. Now, 1 second. Yeah, 1 second. I will going to clarify clearly.
Okay.
M dot EMP number. So employee number. EM dot E name, employee name. E dot manager number. E dot name, manager name. Let's see now. Now, okay, 7902 Ford, right? Now we're going to see that data. 1 second. Okay, I'm going to taking this all the data coming out of from the table. Clear? Okay. Yes, Mansa, you can going to tell me, is it the data is coming correctly or not? You can compare it now. See now, 7902 Ford. Who is the manager? Ford. 75?
7566.
7566. I think it is wrong, right?
It's Jones.
Right, it's Jones only, right? Correct, right?
Yeah, it looks like.
let's stop the record into manager number, e dot manager number. Yeah, now you can see. 79, 1 second. No, you can display manager number also. We'll try that also. 1 second. E dot mgr. Now you can see employee number 7902. Okay, is board. One second. Where MP number equal to 7902. 7902. You can search. Who is Jones? His manager is 7839. 7839. No, it's wrong. That means this is going to display it wrong. M dot manager will see. Now 7938 is the 7902 is port or port only, correct. Employee is correct. 7566 is the manager. Correct only, right? 7566. Jones. 1 second. 7566. So you understood, right, what I am trying to doing. So I try to Jones, correct only. So you can see the results now. So employee number, employee name, manager, manager name, manager number, manager, that particular employee. Now Ford employee is Jones and Scott employee is Jones and Blake. How this record is coming means. So here what I did, so MP table, my manager is going to see why it is going to self join is required. Manager as well as employee, both are in the same organizations.
Yeah, now I got it.
Right. Now try to understand it. The requirement is all are employees in the organization, right? So
Yes.
depends on their position. Some people are managers. Understood? Manager also have employee number. Employee also having employee number only. Okay. So that is the reason you need to differentiate it. So you will going to try to enable changing. Now you are taking the same table in 2 times. One you are going to identifying employee records. One you are going to identifying manager records.
Manager.
Now you are trying to joining with the employee and manager. So what will happen? So whenever it is going to matching at the time, you should have to take the alias into differently. For manager records, you will going to take it into employee record. Employee record is going to take it into manager record. So then it will going to show the proper result here.
Okay.
Okay. So try it. So I will going to help you in more. So if you got any questions, okay. So that is called as a self join. So natural join means just you can join with common columns only. No one is going to using natural and all. So one more is going to outer joins is more important. Outer joins give the non-matching records along with the matching records. Okay, see, outer joins is very, very important. So try to understand it, Manasa. See, whenever we are going to using outer joins, we have 2 type of outer joins: left outer join, right outer join. So today we are going to see this outer joins. Outer join is nothing but it is going to picking the data from based on the left side and right side conditions. We are going to picking the data. Okay. Now, outer join, we have left outer join and right outer join. So let's see practically how this is going to happening. Now, you have your data in employee table. Okay. So you can see some employee data here. Okay. And then you have the data in department table. So you have the data in department table, right? So here you can see some department details here. Now I try to pull both the data in single table, empe, comma, dpt, d, where e dot emp department number equal to d dot department number, dpt number. So now see, now you are going to see complete data, employee data as well as department data, right? Yes or no?
Yes.
How many records is coming? Total 17 records are coming. You can see in the down rows 17 of 17 total records, total rows. Yes or no?
Yes.
Right. Now if you go into employee table, can you see how many records it is? In employee
18.
table 18. Okay. So 18 records, but here it is showing only 17 records. Reason? One
Because
record,
you are joined.
one record is not matched with the department table, right?
Okay.
Now, if you want to pick that record also, how we can do that? If you want to pick that also, you can put into outer join. You can use. So this is called as a right outer join. See now why it is coming 20 records now. Now 20 records are coming. That means, see, 20 records are coming means right outer join means. Show me 1 second. Let me show you here. Say this. Can you read it once, madam?
Left outer join. This will display all the matching records and the records which are in left hand side table, those that are not in the right hand side table.
So now here we can see 1 second. Now here you can see two tables now, right? The join condition E dot department, D dot department. Left hand side and right hand side you can see now and compare it. Which one will going to display full, which one will not going to display. See, again read it one more time. This will display all the matching records, and the records which are in the left hand side table, those are not in right hand side table. Understood? That means here in this, in the department table, if it is, see, in the employee table already there are not, you can forget about. But department, all the departments is coming, even not matching also. Understood? See now, if I'm putting into the
Your
giant.
voice is breaking, sir.
Okay, now I think it's fine.
Hello.
Hello, yes. Now it's fine.
I did not understand what you said before because your voice was breaking.
Yeah. I will try to explain it again. Okay. So whenever you are putting plus sign into left side, right side, all the records will going to print. Okay, understand?
Okay.
So whenever you are putting right side, left side, all the records is going to print.
Okay.
Okay. Now we are into right outer join. This is called as a right outer join. Right outer join means even it is matching or not matching into left side, it will print.
Okay.
Now I will going to write it. All left side records will going to match. Will display all left side table records will display. Okay. Even even not matching with the right side. Even not matching with right side. Are you clear now?
Yes.
So now you want to see the result, you can see this result. 40, 45, 50. These records is not matched with any record in the employee table, but still data is coming. Understood? Now the same example, you can take it into now left outer join. That is right one, this is left one. Okay, now you can see. Now how many records is coming? 18 records are coming. 18 records, which one is coming? Extra one. You can see somewhere the department is not, employee is not matching with any department. See, this is, there is no department itself here. But see, this is going to, now this department number itself were not there. Understood? You got me right? One record is there. That one is going to, there is no department number in employee table, but still it is going to showing that. Simple logic again here also. All right side table records will display even not matching with left side. That is the one. Clear? So again, I will going to write it. So now, so where this is going to using, madam? Sometimes what will happen? One second, let me write it. Outer joins is very, very important, madam. Okay. So let me show you right, and then here it is going to left. So this is one. Now I will going to show you one real-time example. So already it is in Oracle level. So PO headers view, headers underscore view. This is called as a view. So view is nothing but a SQL query, combination of tables. Go to source. See such a big query, you can going to see here. Okay. So I open new tab. So here we can see. Correct, madam. See now. Forget about what is the tables and joins here. Left outer join you can see. V dot vendor ID, right outer join, POH dot vendor ID. That means this header ID, vendor ID is even if it is not matching with vendor ID in vendor's table, but record is still come. Understood? So can you try to read this once again? All the left side table records will display even not matching with the right side. Understood? Now, not matching with right side. Now, in this V table, V means PO vendors table. In this V table is not matching with the PO headers, but record will come. In the similar cases, all wherever we are going to using all the right outer joins, this is. Even if it is not matching with the employee table, okay, but this table is record is there. If it is not matching with this record table, but still record will going to display. So what you understand? Tell me that I can able to give it differently.
I understood only till the right hand side table, whatever is there, you will get it. If it is there in the left hand side or not.
Right, same thing. In the same part, if you put left side, right side will come. Okay.
Yeah.
If you put right side, left side will come.
Okay.
Both just vice versa. If the plus sign you are putting right side and left side you are putting left side, all the records will come. Right, left side you put right side, all the records will come.
Okay.
Okay, so that is the what. And situation, you should have to understand when that requirement is comes. Understood? Concept wise you are clear now where that situation will come and how to apply that. Now suppose, now if you go and see this POLC table is there. Now in this POLC table, lookup
LC.
PO lookup codes, right? What we did here, POLC of lookup code authorization status. That status, let's see. In this table, you can going to see that PO, what is that we are going to know? Lookup code, right? Now you can see the lookup code equal to authorization status. Is it there?
No.
Let's join that. Okay. It's there. Okay. Data is there. Okay. Lookup code. I think it's not there. Lookup code, right? Lookup code is not there. Understood?
Where it is not there, it's there, right?
Not a lookup type. No, I'm talking about, sorry, lookup type data is there. Okay. So even if the data is not there also, it will come. One second. One second. I will going to clarify you clearly. Now, so status is there. Let's see. Now 9 records are coming. One second. So I removed that condition. The 9 records is coming. Even so, I can't insert now. Let's 1 minute. I will try to explain little bit different. So you got it, most of the records. Now, can you see here, document is there, error more info is there, manual or automatic is there. So many different PO segment is there. So many things are there. Now, here you joined only specific few of the records here. Understood? But this data also will come. Document also will come. But even if your join is there, authorization status, FOB, and freight terms and pay on code also. How it will come remaining all the codes? The reason is you are going to using write outer join. Got it?
Yes.
Okay. So like that way it's going to working. See, it coming means the reason is they are trying to pull the complete data, whatever it is available into lookup type. Even these conditions is existed. These conditions are, they want to pick this data along with the remaining data also they want to pick. Okay, you can use it, just try a different way, and then if you still have questions, and we'll explain more.
Okay.
Right. So that is the one. Next, moving on to the next full outer join means you will going to get both the sides. But most of 99% you will not going to use this join. Only either you can, yes, either you can going to use the left or right. But full outer join, most of the cases, no one will going to use. Now you can see this full outer join. You should have to use the keyword full outer, full. outer. There is no plus button to you can going to use left or right side. Say 21 records, even all the records from right side and left side, even matching or not matching.
Yeah, I got it.
Now you can see one record is not matching with the department table, but record is coming. 3 records are not matching in employee table, but still record is coming.
Because it's full outer join.
Right. So if you want more understanding, then I will going to put it into star here. Yes, you can see, madam, now. If you go down, one employee is existed, but there is no department mapped to that employee, but still record is coming. 3 records are departments are there, but there is no employees for that, but still records are coming. So inner join and all, no one will going to use this. Okay, just you can, if you want to look it, but most of the cases there is no use. See, now joins level, what joins you are going to doing? Equi join, non-equi join, self join, okay, and outer joins. These are the major important joins. You will going to use it into, depends on your requirement. You can going to use the joins. Okay. Right. Shall I move to the different concept now? So we can call it as a, this is called as a subqueries. Okay. Subqueries is nothing but a query within the query. Is called as a subquery. Nesting of queries, one within other is termed as a subquery. That means the query is there. We will going to write it one more query inside of the query. We can call it as a subquery. Okay. A statement containing a subquery is called as a parent query. Suppose whatever the main query is there, that query we can call it as a parent query. The dependent query will going to call it as a child query. Okay. Subqueries are used to retrieve the data from the tables that depends on the values of their table itself. Right. So that you will going to see example and you will understand. Subqueries are divided into again 4 types. Single row subqueries. That means it is going to return only single value. Multi-row subqueries, it will going to return multiple values. Multiple subqueries, correlated subqueries. Multiple subqueries means query within the query within the query. Will going to write it like that way. You can call it as a multi subqueries. Correlated subquery means it's definitely it is going to depending on the child query. Child query will return the record, then only parent query record will come. Otherwise, it will not come anything. That is called as a correlated subquery. Right. Let's see into the single row subquery. So you will going to write it into multiple different styles. You can play it. Okay. So what can you see this query and tell me what we can going to frame it? This example now, can you frame the query statement of this query? Right. Mansa, you are able to see my screen, right? Yeah, please. See, now can you please help me how we will going to frame this statement of this query? Yeah, can you frame this query to get? Hello.
Yeah, I'm there.
Yeah, please help me. Query to get.
Query to get?
See the below query and tell me how we can frame the statement.
Get salary.
Query to get salary.
Salary where employee ID is 7566.
Can you look it again one more time, query?
Greater than get salary greater, select salary from employees table where employee number is this.
Query to get all employees, not salary. All employees. First query to get all employees. Yes or no? See, query to get all employees. Now
salary is greater than salary of 7566.
Right. Salary is not greater than, more than you should have to write. Okay. All employees. And and more than, and salary more than employee number
number
7566.
7566.
Now tell me the query, how we can write it.
Select star from employees where salary greater than.
Okay, where salary greater than,
open the bracket.
how we will going to know here? Open the bracket.
Select star from
EMP table only, right?
Yeah, EMP table where salary, employee ID.
Salary or employee ID? Madam, see, query to get all employees. Yes, you done. Select star from EMP. More than whose salary is, whose
salary is
this guy.
Yeah. Where employee greater than where employee number equal to 7588.
Is it correct now? Yeah, tell me.
Text from employee.
Is it correct now? Too many values. See, salary more than whose salary is this employee number. Here you should have to put salary, right? How system will going to comparing? First it will take this salary, okay, and then it is going to comparing with this salary.
Okay.
So why single record also not coming? Because maybe not matching, right? Yes or no?
Okay. Yeah.
Records are not matching. No one is there.
No, we have to put 7588 instead of 66.
Okay. Yeah. 7566. Right. Yes. Now you got the records. Now are you understood?
Here also you have to change into 66 number.
Yeah. I will do that. Okay. Yes. Now tell me you understood, right?
Yeah.
This is called as a single row subquery. Why I called it as a single row?
Because you got only one row.
Where I got only one row? Here I got multiple rows, right? Here you will got a one row. Understood? Subquery is going to giving a single row.
Single row subquery. Okay.
See, single value.
Okay.
Single row subquery. Single row subquery means the subquery is going to return a single value. Then it will going to matching with the main query. Say this is the one. Instead, without using this subquery, is it possible to get this value? Is it possible to make a query results?
What?
Without using subqueries, this statement, are you able to frame the query, SQL query?
I think so. We can do that.
Yes, how?
By using joins?
Tell me, if you whatever you are thinking, you can tell me. But without using a subquery join. Tell me how
Select start
employee
from
table is there.
employee, where salary
Okay.
greater than or equal to
How would you know this 7566 employee salary? You don't know, right?
No, I don't know.
So how you can join now? Okay, you can think and do it sometime. Okay.
Yeah.
Okay. You can do it into different conditions, madam. Here, either you can use the less than, either you can use greater than, or you can use equal condition. Okay. Okay.
Okay.
These are all the conditions you can use here. Okay. And not only here. Now you can going to get it into where different questions you can going to frame it. Who's more than, who's less than, who's equal, whose job is manager, only that manager job guy. So, but always single row query that is. Now let's go into multiple row subqueries. Now, in the multi-row subquery, it will return more than one value. In such cases, we would include the operator like, or, any, or, all, or, in. Okay, or not. In between these comparison operators and subquery, we can going to use. So, whenever you are going to performing multi-row subquery at that time, you should not going to use the comparison operators. You should have to use the in, or all, or any, or these things you should have to use. Can you please help me to frame the statement for this?
Which one?
The below one.
This is single row, right?
No. This is one I'm talking about.
Yeah, that one only. Single row, right? You did not. Oh, you put any. Okay.
Tell me the frame.
Need to get all employees.
For you to get all employees.
Salary. Yeah, where salary is greater than that.
Whose salary is more than?
More than. Between more than 2,500.
No. Whose salary is between, you can write, not more than.
Between 2,500 and 4,000.
2,500 and so
4,000.
I will going to put one more zero here.
25,000.
40,000.
And 40,000.
Okay. Yeah. Tell me. Correct, right? Why? No records are there. Shall we see the data? So anyone is there?
No.
That is the reason records is not coming. You can put it into 55 to 65. Okay. Where?
Now you can run and see.
See. Got it, right? Now.
Yeah.
How the data is coming now? Try to help me. First, which one is executed?
It's getting executed. Select start from employees where salary between 55,000 and 65,000.
No, madam. Here, two SQL queries are there. First and second. Which one is executed first?
Second one.
Right. Based on the second one result,
first one is coming.
First one is coming. Right. See, can you see here? How many records is coming?
One record.
But here it is coming only one record. But going to here, it is coming multiple records. Now suppose I removed any, what will happen?
One record will come.
No, 16 records are coming.
Means all the records?
No, not all. 16 records are coming. Now tell me what is the difference between any and without any?
Same, you're getting 16 records, right? With the any also?
See, 16 records, correct. Now, what is the use of this any now? If you are going to getting same records again,
It's no use.
but why we want to use any without no use? Definitely
Because you're
use.
getting same.
One second. Definitely any use is there. Otherwise, will not going to use, right? Let's now if I'm going to putting any and all, let's shall I put all
Yeah.
instead of any?
Again, you put any.
No. I'm going to copying that.
Oh, okay.
16
Same
records.
records.
Definitely difference is there. Okay. That we should have to understand now. What is the difference between any and all? Okay. So records maybe it will going to give. One second.
Yeah.
See, the problem is these guys data is going to deleted proper data. So this is the dummy data they are going to insert it. Some people are going to insert it. Let's insert the data into the table. Give me a second.
Sure. But you're getting both a 16 records. So
that is the what the data is not correct properly.
Okay, got you.
One second. If you put proper data, maybe Google we will going to get EMP table data script. EMP and DTPT. Okay. What we will do, we're going to drop the table and we will going to insert this data. Okay.
Okay.
So I don't know. Somebody is going to inserted this all 55,000. This is not the correct data. So drop table name EMP. Yeah, table dropped. Okay. The similar kind department also you should have to drop. One second now. I'm looking on the department table also there are not. Okay. Department also there. Let's we'll going to drop that also.
Okay.
Drop table DVD. So you will going to get it everything in Google, madam. Okay. The way of searching is required. The way of your taking and working style is different. Okay.
Okay.
So you should have to use it into Google thoroughly. This is the department table script. This is the employee table script. You can see the foreign constraints. Constraints you can see there. Okay. So let me going to create a table. Yes, table created. Yes, table created. Now we can insert the data into the table. Okay. So up to you can take. Okay. So one row is inserted, second row is inserted, fourth row is third and fourth. All are inserted now. You can do the commit. Right. I try to go to employee table. Here only starting employees, right?
Yes.
Hmm. Okay, right. I'm trying to inserting the data into the table. One row is inserted. Second row inserted. So third row inserted. Fourth row also inserted. So fifth row also inserted. So this is already done, right? Okay, let's say now. Okay, no. Who is missing? 77782. 18 records, 14 records should have to come. I think one record is missing.
One is expired, right?
What is expired? See now here. So 1, 2, 3, 4, 5, 6. So how many it is? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, it's a 14 rows it's showing, right? Only one is missing. Who is missing? We want to see that. 1 second. Let's some record is not inserted.
Okay.
If I try to insert again, so unique constraint. Unique constraint. Unique constraint. Unique constraint. Did I copy or I missed it? Unique constraint. Unique constraint. Unique constraint. Unique constraint. Unique constraint. Unique constraint. Constraint. Unique constraint. Okay. Maybe jumps is missing. No. Unique constraint. Oh, the last one, Miller is, I missed it. Yeah, now 14 records, right?
Okay.
So now I inserted the employee records and the department records. Okay. So I did the commit. Now you can see the example. Okay. So now you will go and run your example. So where we are in? So we are into here, right? The first one,
Yes.
any. Why? Okay. Now we need to change into 5,500. What is that? Query to first to select what is the whatever we are going to doing initially. 2,500 and 4,000, right?
Yes.
Okay. So 2,500 and 4,000 you can play.
2,500.
Yes. And 4,000 you can play. Okay. Right. Now you can change into accordingly that 2,500 and 4,000 you can play. Okay. So now how many records you got?
4.
4 records. Now are you able to see in between records only?
Yes.
But why it is coming 5,000?
Because you put 4,000, 4,000, right?
See, I asked about in between 2,500 and 4,000.
Any you put because of that?
Yeah, in between only it should have to come, right? Why it is coming 5,000? It should not come, right?
Yes.
But due to now go and check this all condition. All. Only one record, 5,000. Now see, the second query will going to return same results always. How many records are coming?
4 records.
4 records. Okay. Now in the down also we're going to see same
1 record.
4. I'm talking about second query.
But before we got only 1 record, right?
No, see, I'm not executed full query. I'm executed only the second query. Selected and only the second query I executed.
Okay, got you.
Okay. Now, whatever the output is coming, read
4.
it once.
2850 2975 3,000 3,000.
Correct. Right. You understand. Now both the queries, second queries are written the same result, right?
Yeah.
Now, if you go into any, how many records you got it? 4 records.
4 records.
Here you got it only 1 record. How any and all is going to working? Any and all.
All.
So all is going to comparing with the result and it return the highest value.
Okay.
Comparing with subquery result. Subquery results and return the highest value. This is going to same comparing with the subquery results and return the lowest values. Least values. Got it?
Yes.
Least values. Let me show you. Least
values. Okay.
See now. Now let's run the subquery now. What is the least value?
2859.
Right. From 2859 to okay. It is going to displaying remaining all the values in the whole result. 2850 will not come. More
Okay.
than 2859, what are the records are there, and it will come all the records.
Okay.
See now, are you able to see?
Yeah.
Remaining all the records is coming. If you go into all, what is the highest value?
3,000.
More than 3000 remaining values only will come for all.
Okay.
Now are you clear? Any is comparing with the least value and return the all other values. Got it?
Yes.
This is going to return the all values comparing with the highest value.
Okay.
So you clear now? What is the
Yes.
difference between all
Any
and
and all?
okay. So think about when you are going to using those keywords, keep on mind those. Okay, how it will going to working.
Okay.
Right. Multiple subqueries. There is no limit on the subquery, which subqueries will going to use. So now can you please help me? Can you frame the statement of this SQL query? Right. Don't see the result. Okay. 1 second.
Okay.
Now you can tell me this below one. Can you frame the statement? Query to get employees.
Where salary equals where salary.
Now go with the down. Don't go with the top.
Select maximum salary from employees
first,
where salary.
here we are getting maximum salary. Again here you are getting maximum salary, and finally you are going to displaying that salary. Query to get
maximum salary.
First maximum salary, second maximum salary, and comparing. Query to get second highest salary. Query to get second highest salary. This is the one. How you are going to getting second highest salary? First, what you are doing? You are going to getting the maximum salary, right? So you can try to. So right. 1 second, madam. Now 5,000 is coming, highest salary.
Yes.
Correct, right? Again, here you are going to getting again maximum salary. Yes or no?
Yes.
Here maximum salary, what you will going to get? 5,000, right? Now salary is going to less than this highest salary. What will come?
Less than the highest salary?
See, now try to run this query only, this much query.
5,000.
3,000. How 3,000 is coming? See, here 5,000 is coming, right? Now 5,000, see, try to divide the query and understand, okay? Now see, until what will going to happen? What it is coming? 5,000 is coming. That means you can go
maximum
into
salary.
right. 1 second. Now 1 second. Now this is gone. This statement is gone and it is coming to 5,000.
Okay.
Now if you ran this, select max salary, where condition we are putting? Where salary less than 5,000. That means second salary is coming.
Okay.
You got me right?
Yeah.
So what will come here? 3,000. Okay. Now you will going to divide that again. Now this is gone. Total will gone this. Now what will coming here? 3,000. 3,000 it will come. Correct, right?
Yes.
Okay. You understood or you want to explain one more time?
I want one more time to be explained.
Nothing, madam. See, in this query, how many statements are there?
3.
3 statements are there. Which statement is going to execute it first?
Last one
Right.
means select the max
This one.
salary from employees.
Right. This
So
is
highest salary you're getting.
right. This is going to, you are getting highest salary. Right. Now what will happen? So now where salary less than 5,000. This is right. Query is going to minimize it now. I mean, here only you will going to, just for your understanding, I divide it like that. Hello?
Okay.
5,000, less than 5,000. Now this query is going to return what? 3,000. So finally you will going to get 2 records. So this is on, this is if you run this query, only 2 records will come. This is the second highest salary people. You can write it n number of subqueries like this way.
Mm-hmm. Okay.
Until 256 queries, you can going to write it.
Okay.
Okay. So correlated subqueries. Correlated subqueries, a query is equated once for the entire parent statement and correlated subqueries evaluated once for a row processed the parent record. Yeah, this is a very different one. So how it will going to happen means, first it will going to happen the parent query. Okay. Based on the child query will going to exist. Now we can see. So we'll share you the assignments. Okay, don't worry, we'll get more. Now say this. This is called as a correlated subquery. Now, whatever the statements it is, see, is it possible to execute this query? No, you can't. Correlated subquery is nothing but the child query will going to dependent on the parent query. Parent query exits. See, you can't going to execute separately in both the statements. Understood? The reason is you can see here e dot emp number equal to d dot department number. You joined with the parent query, join in the down. Can you frame it? What is the query statement? Query to get, hello?
Yeah.
Query to get departments. Query to get departments. Which department having more than 5 employees? Yes or no?
Yes.
Okay. Now how, what we're going to do? You are going to get the count of employee name from the employee table based on the employee table and department table count. Department table join. Okay. Now you got the count. So now you are going to comparing with the main query again.
Okay.
Understood?
So confusing.
Nothing. Oh.
No, I did not understand.
1 second. Now
Yeah.
are you able to see my screen now?
Yeah, I can see a screen, but I am not able to understand this one.
Simple logic, madam. First query, what we are getting in the last query?
We are getting
employee count
of the
employees
from department, from employee table.
Just we are getting the count of the employees based on the employee and the department table join.
Okay.
There is no department table here. Simply you are rejoining the same table in twice.
Okay, got it.
Okay, so main one you are going to comparing more than 5 employees. Now you can see only 30 and 20 departments having more than 5 employees.
Okay.
Correlated subquery, why I said without the parent query join, it will not going to perform. This is called as a parent query join.
Mm-hmm.
See, e dot department number is there, right? Parent query join. So that is called as a correlated subquery. Can you read it? A subquery is evaluated once. A subquery is evaluated once for the entire parent statement, whereas the correlated subquery is evaluated once for every row processed by the parent statement.
Parent statement.
Right. So that means always it is going to evaluate it based on the parent query, and condition is going to checking in parent query is executed only once. See, if this count is coming means parent query also executing, right? E dot department number is there.
Okay.
That is the what we are trying to saying here. So correlated subqueries is nothing but it is going to executing the query based on the parent parent giants child is going to executed. So now you can, this is already you are seeing how it is going to execute means based on the employee join department is going to execute it. So now how to use exits and not exits conditions. So this is going to really, it's very helpful. Exits is going to always see, suppose if you are using this keyword, performance is going to increasing. See, suppose you want to display the department number which is more than 4 employees. Yes, you can going to use directly exits condition also. So how to use exits condition? So you can going to see, let's see. So it's more than. Now, sir, exits condition how to use? Suppose now, let's start from EMP where, okay, where employee number exits. So exits, you can going to write it here, whatever the condition you want. Select EMP number from EMP table where, okay. So here you can going to give it as a DEPT number equal to suppose something. So now how it will going to using this exits condition now? Invalid operator. 1 second. Exits, some condition you should have to write for that exits. See, exits function is the test for the existence. This is a logical test for the return of the rows of a query. So how this going to working means in 1 second. See now. So what is the use of this now? See, even if I'm putting only department number 10, right? But still it is coming everything. Suppose I'm going to changing now, not exits. Nothing is coming. That means, say, this exits and not exits, how it will going to helping means, always it is going to checking the child query, whatever the child query is there, this query returns a true or false statement. Understood? Whenever this is true, that means at least one record is existed, then it will going to display complete condition is going to true. Understand?
Yeah.
So if it is not returned any record, that means false. The whole condition is going to failed. Keep in mind that is. So we are going to using multiple places exits conditions. So moving on to the next one. So this is going to, can you please help me, madam, this, what is the statement we can going to frame for this? Yeah, you can try to help me this. What we can going to frame this query. Look the query and give me the statement.
Number, e-name, count from the employee, group by department, number, e-name, having, count less than 4. Okay. Give a department number and e-name. Count from employee. Getting department number, e-name, and employee's name. Count from employee group. Grouping by department number and e-name less than 4. Department number, e-name. From employees table. Grouping by department number, e-name, and count less than 4.
Okay, I'm talking on mute. Okay, so you can try to help me that query now.
Okay. You're getting department number, employee's name. Count of employee's name and employee's name.
No. Query to display more than 4 employees department and as well as employee names. Understood? So see the 4 employees, more than 4 employees, how many departments are there? That information we want. Query to get the department info. Okay. Who belongs to more than 4 employees. Okay. Employees, more than 4 employees departments. More than 4 employees departments. 4 employees departments. Correct, right? So how many records will come now? ఆన్ చేస్తున్నాను, చేంజ్ చేసుకున్నాను. సరే, నెట్ కనెక్ట్ కోటి కూడా ఆన్ చేశాను చూడు.
Hello.
Yeah, some power gone and came back.
Okay.
Right. So yes, madam. Now you can see that. See now how many records will come this query if you are going to executing.
Employees department. The last part doesn't make sense. More than 4 employees department. What does it mean?
See now that only you try to understand and help me. What will going to happen if I am going to executing this?
You will get department number and employees name. What count of all the rows you will get from employees table.
Why it is not showing anything?
Because maybe you don't have.
Right, which condition failed now?
The last having, I think.
Having only, correct only. That statement is correct only. Yeah, if I commented last one, see now you got a record there. But when I am going to enable this, it is not getting any data. Now you can help me.
Because grouping and having you cannot have together.
Madam, see now, if I am going to here, what will happen? Employee department number, comma, e-name, comma, department count of star, right? So now you are grouped by department number and e-name. And most of the employee names are unique.
Okay.
Yes or no? So what is the count will come? One only
Only
will come.
one.
One only will come. See, always one only it will come. Understood? So
Uh-huh.
whenever you are using having condition count of more than 4, condition failed. That means no records will come.
Okay.
Understood?
Uh-huh.
Now
But here,
hmm,
what you written on the top, more than 4 employees
yeah.
departments, what does that mean?
See, query to get, okay, query to get, 1 second, query to get department details. 1 second, query to get department DPT number, comma, DPT number, e-name, and count of employee, hmm, okay, count of employee, having, okay, belonging to more than 4 employees in department, belonging to more than 4 employees, more than 4 employees. Now you understood?
Yeah.
So this is the one. More than 4 employees count to. Whenever more, same people, 4 people are there, then you will going to get this record.
Okay.
So now this is not giving. So now, so how we will going to do this? The same solution you can going to use into exits condition. See, the same result only it will come, but here you are going to using exits condition. So now you can see that the same example above you are not getting. Now below you will going to get. So what we will going to doing? Where exits select star from EMP table E2 E1 dot department number E2 dot department number group by E2 dot department number having count employee name more than 4 count and it's outside of the order by clause. Now you can see now these are the employees it is going to selected. Now, sir, why it is not giving the above example and why the below example is going to giving the results? The reason is the below you are going to using exits condition. Understood? Exits condition and subquery you are using. Correlated subquery. So correlated subquery means what will happen? So the main query E1 joined with below child query. Correlated subquery means always it is going to executing the parent and child. Both are combination, it will going to execute. Now you can see here. Are you understand below query?
Yes.
Yeah, you can see now. Same, the above whatever we are done, below also same, but the difference is we are using exits condition. So what will happen? Always it is going to checking this condition, this much condition only. This condition is going to, whenever it is true, record will going to display. So how it will going to true? This is going to once department number both it is matching, then group by department number and having e number is more than 4. So count will come always here. The reason is the below table we are going to checking. It is not checking into above one. Only the below subquery checking and it will going to display. Okay. So practice it. So you will going to get all the things. So same if you want to, if you are going to using not exits, it will going to not belonging to that category. It will come. So whatever it is count greater than 4, right? So if you use the not exits, so who are not belonging to more than 4, those people will come. See this. These 3 this department is not belonging to more than 4 employees. Only 3 employees we have. Got it?
Mm-hmm.
So this is the one. So subqueries we done. So I already gave it more assignments in for the subquery, joins and operators and functions already. So try to
Mm-hmm.
look at all these things and practice it those things.
Okay.
Let's next we're going to start into synonyms and sequences. Okay, 1 second. Right. So you will going to see here 1 second. Create a sequence number. 1 second. So
Mm-hmm.
so next concept is you will going to see the view synonym sequences. These three
Okay.
you will going to see. These three are the next concepts. More concepts you'll going to see those. What are those?
Okay.
V- Views, okay,
Mm-hmm.
um, sequences, and synonyms.
Mm-hmm.
Synonyms, okay.
Mm-hmm.
See, these are the views, sequences, synonyms you're going to see now. So let's start from the views. Right. Now you can go into the major views is not missing. 1 second. Yeah, 1 second. So these are the views concepts, madam. So first of all, try to understand what is a view. A view is nothing but a snap of the SQL query. So backend will going to see. Just let me explain it clearly. So see, suppose now when views requirement will come means. So the first day demo I explained, totally you are not understanding, you are getting confused about this concept. Okay. Now I will going to explain again for you. Suppose now you want.
Yeah. Now I can see your screen.
Right. Thank you. Oh, right. Now just forget about what is this form and what is this, these all the things. Just what you can going to focus it. What you mean by the view, how it is going to helping in this real time picture. Okay.
Okay.
So now I just go to the some purchasing related information. So normally this is going to helping where how the purchase orders will going to creating into Oracle. So here you can see let me get some purchase order number in the backend. Okay. Order by creation date. So now recently created a purchase order I took. So now let's go on to now. So now this is what we can feel it. This is a one form, right?
Mm-hmm.
So entering details form. So you will going to enter the purchase order into in this form level. So
Okay.
now what you can going to do, you will enter all the details and you will save the form, right?
Mm-hmm.
Normally what you will do, suppose as a front end user, what you will going to do, you will going to enter all the details. So you will going to save the form, right?
Yeah.
So now once you saved, where this information is going to stored?
In the database.
In the database, correct, right? Now if you are going to see in the form, in the starting, see purchase order details 6247, here PO number is there, suppliers, ship to location, means the material is shipping to where, bill to location, the material bill where we have to send up. A buyer means who is going to buying the material. So type of the purchase order. So you will going to see some different fields here, right?
Mm-hmm.
So these all the fields is not going to stored into single table. It's going to stored into multiple tables.
Yes.
Supplier table is different, location table, bill to ship to is going to different table, supplier and supplier site is different table, PO number is a different table, buyer is a different table, okay, and the PO
Mm-hmm.
type is a different table. Now in now almost how many tables you got? Around 5 to 6 tables you got here. Only
Yeah.
header, only this much level, not into lines again.
Okay.
Lines are different again, only in this level, above top level. Now tell me, madam, how did you going to insert or getting the data in this table, in this multiple tables? How you are going to getting from the data from the multiple tables?
By entity relationship.
So you are joining, right? Entity relationship, joining the tables, right? So, but see, how many times you will going to write a SQL query? Always. Is it possible all the time? You will suppose now around 500 lines SQL query is there. Are you going to execute always 500 lines query? Is it
No.
easy? It's
No.
not easy, right? So what you will going to do in the top of that SQL query, you will going to create a view.
Okay.
Understood? Once you create a view, the view you can easily you can able to execute it.
Okay.
See now, just I record history. What is the view name, madam? This is PO headers
This
V.
table name, right?
But table name only. PO
Okay.
headers underscore V. Now if you go into PO underscore headers view, you can see the, so F4 you can press, okay? So script you can going to, you can see the script. You will going to understand the what you mean by view. Now can you see, madam? What is this? Can you read it once? Create or replace?
Create or replace post view.
Force view. They are going to creating a view on based on what? Select statement. Down you can see the select statement. See, this is a big SQL query. Got it?
Mm-hmm.
This is a query, madam. This is a query. Okay.
Mm-hmm.
On top of this SQL query, they are going to write the view. They are going to create a view.
Okay.
Understood? Instead of executing this big SQL query, what you can do? Simply you will going to do the select star from PO headers view. So now you understood view is nothing but a combination of SQL tables with joins. A SQL query. View is nothing but a combination of the SQL query.
Okay.
Clear?
Yes.
Okay. So next what we can do, let's go into our concepts. That is real-time case. Now here we're going to see the simple view. A view is a database object that is the logical representation of your table. So logical representation of your table. That means it's not going to exactly, and data is going to stored into views. Can you help me? If I'm going to saving one record, the data is going to stored into in this view.
No, in the table.
Yes, in the table it is going to stored. But what you are going to do, you are trying to retrieving the data based on that those tables using this view.
So
Okay.
basically, you say in view you will not have storing the data.
Right.
In table
Right.
you will be storing,
Data.
and view is just only view purpose
Just
or seeing.
logical representation for
Okay.
only seeing purpose. Okay. It is delivered from the table but has no storage of its own, and they may be used in the manner of this table. Okay. A view taken output of the query, right? Output of the query, and it's translate into the table. Got it
Okay.
right? So
Yeah.
the SQL query, what is the output it is coming? That output is tried to displaying into the as a table.
Okay.
Got it? Now views are going to divide it into two types: simple view, complex view. A simple view is nothing but a just a single table. Whenever you are going to creating a view using only single table, understood? That is called as a simple view. Whenever you are using more than one table, you can call it as a complex view. So provides the additional level of the what is the use of the view? So you can read here, provide the additional level of the security by restricting the access to predefined set of rows and columns of a table, hide the data complexity, and simplifying the commands for this user. So hide the restriction means, see what, suppose you joined as a fresher or you don't know, see simply what you will going to do, you will going to execute the query. So at the time, you don't know what is the SQL query beyond that, right? Yes or no?
Yes.
That means so what's going on in the back end you don't know. See, some simply you are going to doing PO headers view, but what is the beyond this you don't know. See, if you people know technically, those people only will go and see inside of the query. Most of the people they will never going to see inside of the table, that is view query. So that means security you will going to get. Yes or no? Correct, right? Provide the additional security level of restricting the access to predefined set of rows and columns. In the back end, what is the query it is there? People will not going to see that. And next is going to hide the data complexity. So it's going to hiding the what that you will not going to see the complete data. The reason is only based on the conditions data only it will come. And
Okay.
simplifying the command for the user. Yes, instead of executing the 500 lines SQL query, okay, simply you will going to running single line view. Yes or no?
Yes.
So now going into read only view and view with group by. And so we have different type of views. Only read only view you can do. So read only view means only you can going to execute it. You can't insert and update into that view.
Okay.
Okay. And a view with group by, view with aggregate functions, view with row num, view with partition views, and view with distant keywords. These are the different type of views you can going to play in and around.
Okay.
Understood? So now if you go and create a simple view, create a view. So you can going to create a views under the tables also. Understood? Simply you will going to create a views. Following or getting bored?
No, I'm following.
Okay, fine. So now simply create a view name as select star from department. So department with read only. Now suppose I'm going to executing this.
But 1 second. You were telling about complex view and simple view. You said simple view, it's from only one table.
Right.
Complex view, multiple table. Then
Right.
again you said you have multiple views. You said like you can.
In the again in the simple view itself, okay.
Oh, this comes under simple view. All these.
Right. Under simple view, we have different ways you can going to create a.
Ways, not types.
Not types, ways.
Okay.
So that is the one. Understood?
Uh-huh. Created. Okay.
So now view is created. So you will going to get the data department DEPT underscore.
But when we saw in the before screen, which you showed me the view in that in the form view, that it says create or replace post view, right?
No. It will come. It will come. Those also. Okay.
That is not this one.
You can going to put here also. No issues. Okay. So now you created a view, right? Automatically system will going to created a backend into the script. You can go and see that. See now.
Oh, automatically the script will be changed.
Right. See now. Yes or no? Change it, right?
Yeah.
So that is the default standard format of the Oracle.
Okay.
So like this, it is going to happen. So just look at. So tomorrow I will going to finish it this views and synonym sequences.
Okay.
Okay. So try to look at. So any questions, please come with questions on tomorrow, and I will explain you.
Sure. Okay.
Right, madam. So maximum I will going to. Right. Yesterday we have seen just views. What is the basic views and as well as the simple view, complex views, and again we are going to see this different type of views we can create using DML statements. Right. So advantages also yesterday we discussed about these views. Now coming to read-only view with group by, view with aggregate functions, view with row num, partition view, and view with distant. See these and all actions you will going to see. Normally simple we will going to create or replace view name and followed by the select statement we will going to do. In the select statement, whenever you are going to using, suppose read only view means you can't going to do any updations. I mean DML actions you can't perform on that. Got it?
Yes.
What do you mean by DML operation here?
Insert, update, delete.
Right. So those things you can't perform in the read only views. Okay. And a view with a group by. Group by means in the select statement, you will going to write a group by statement, right? So in the group by, whenever you are going to using in the select statement group by, so that is you can going to create a view in the select statement level. Let's show you. See, nothing. It is a small, but keep on mind maximum 99% avoid these operations in your regular work.
Okay.
Understood. People will not going to use most of the cases group by or aggregate functions. Aggregate functions means
Addition, subtraction, multiplication, division.
No. This is group functions, madam. Sum, Okay, count to
Okay.
average.
Yeah, addition,
those.
subtraction, multiplication, sum.
That is only arithmetic operators.
Oh, okay. Sorry.
Okay, so you can see here down in that. So you will going to, you can perform these all the operations, but in your regular work, so try to avoid these functions. Okay, maximum you can avoid these things. So now you can see. So see now, create view name department with read only. So yesterday we created this dept underscore view. Understood? So select star from dept underscore v, right? So this is the one. So now let's delete this. Delete view name. View name dept underscore v. Why? Invalid table name. So drop you can, suppose if you want to insert something, insert, update, delete, you can't perform in these actions. Okay, got it right? Now one more is view with using a group by function. Simply see the select statement is group by. Okay, and then next is going to using with row nums. Select with the row num, and this is the student table. Again we are going to creating a view. Understood? Select statements you are understanding, right? Here.
Yes.
Select star from student union function they are going to using here. So this function, this still it is not covered union. So that I will going to teach that also. Select with the distant. Distant means so you're going to get only unique records. Understood? If any duplicates are there, whenever you are going to using distant, you will get only unique records. Distance is used to avoid the duplicate values while getting the query results. Okay. So now what this views? What do you mean by these? What are these views without DML operation views? Views without DML operation. Understood?
Yes.
Okay. Tell me, madam, what are the DML operations using with the views? Can you tell me few of the things? Read only view, aggregate functions, okay? Row nums, partitions, and distant keyword. These all are not acceptable in the views level. You can't do this. Can you read this below things and you will understand little bit now.
Okay.
View with out not null column. Can you read that?
Which was in base table. Insert not possible. Update delete possible.
That means
With not null column. Insert with out not null column.
view without null column which was possible. Insert is not possible. Update and delete you can do. That means what? Already you finished the constraints. Yes, tell me, madam.
With not null constraint they using this.
Right. If you are using not null constraint, okay, what will happen in the views level?
Okay. This one without not null constraint. This is without. So not this is not null. This is not.
No,
this is
madam.
also not null.
First understand what they are trying to saying there. Okay, what you understand? Tell me.
With not null columns. Null column should not be there, they're saying, basically, first one.
So now you are going to using not null constraint while creating the table. In that table, you are going to using the view. So you can't perform the insert option. And you can able to perform the update and delete option. That is the what they are saying.
Okay.
Understood, right? What I am saying?
Uh-huh.
No, madam. See, what is the use of not null constraint?
If you put null in the table, it will not allow you.
That's
called not null constraint.
Right. So now without not null constraint, we are going to using base table. What will happen?
Insert is not possible. Update and delete is possible.
Right. Is it correct now?
No.
Okay. Now above one, not null column, insert without not null column, not possible. See, if you are going to be with not null column means, okay, insert with not null column, not possible. Okay, update not null column, not possible, and delete is possible. That means whenever you are going to using not null constraint in the base table, okay, so at that time insert and update you can't do it. Okay, only delete you can do. Without not null column, you can perform insert is not possible, and update and delete is possible. This guy is going to getting some confusion here. Let me change the content here.
That's what I was trying to look.
Right. Without not null, so insert is possible. Understood. And delete and update also possible. Both. Above one is not possible.
Delete is possible.
So now coming first two, you are clear, right?
No. See, view with not null column. Okay. View without not null column. Okay, now I understood.
Clear, right?
Mm-hmm.
Now see. So you can going to understand now.
What did he write? Update not null column to null is not possible. What does it mean?
See, if you are going to putting not null, see, we with not null column. Not null column means constraint is there. That constraint, if the constraint is there, you can't insert the null values, right?
Mm-hmm.
No. What they are written, that is correct only. Give me a second. Insert without not null column is not possible. Understood? And update not null column to null is not possible. Delete is possible. Correct. What they are written here. Now view without not null column, okay, was base table. So then insert is not possible and update delete is possible. Correct only. So we need to try to understand in depth of that. See, in the constraints, what we done whenever we are using not null. So what it is avoiding the null values to insert it to the table, right?
Yes.
So in the similar case, if you are going to here views with not null column, so what do you mean by that? Insert without not null column, not possible. Understood? So that means duplicate columns you can't insert. And the same thing, duplicate columns you can't update into the view. And delete is possible normally, right? Now coming into view without not null column. With not null column, we are not going to updating in the base table. Okay, at the time, it is not without not null column means without. So insert is possible, right? In that case, not null insert is possible, delete and all are possible at that time. Yeah. So clear, or I want to explain one more time this.
I need explanation one more time. I did not understand it.
First one you are clear.
Views with not null column. Okay. Insert without not null column not possible. No.
See, without that particular column, you can't insert the data, right? See, madam, let me show you. See, last time we did some tables, right? Student table, right?
Uh-huh. Uh-huh.
Now, see, suppose in the student table, so what we can going to do? So now suppose this, I am going to putting not null column as a number. Without this
Okay.
number, is it possible to insert the data? Hello?
Uh-huh. That's what I'm looking.
Without that column, are you able to see not null constant is there, right? Primary key is there. Primary key is nothing but a not null plus unique key, right?
Uh-huh.
Now I try to insert the data into the table. Insert into student. Okay. So values. I'm directly putting name and marks. Is it possible?
Yeah, it is possible.
How it is possible, madam? Primary key, without primary key, are you able to insert the data?
No.
So, okay, values it is asking. Definitely we're going to put the values. Okay, right. Let me put the values. Okay, so name, comma, marks. Why?
Do not insert null into this.
So that is the what they are saying here. Can you read it now?
Yeah. Insert without not null column not possible.
What did this
Okay.
mean by?
You can not if you cannot put a blank in that column. I mean, you cannot leave it. You have to put some value.
Right. So that is the what they are trying to saying here.
Okay. What about the second one?
Second one, yeah, read it now.
View with out not null column which was in a base table. Insert possible, update,
No.
delete.
Insert actually they are written not possible. So understand and tell me now. In the base table, suppose, okay, view without not null column, which was in the base table, okay, insert is not possible, update and delete is possible. So that means this, whatever the not null column is there in the base table, if it is not there, you can't going to do this for action. Similar again, similar is both are similar only. See, with
Then what is the difference between view with not null column without not null column?
Here they are going to applying directly into the view. Here they are going to applying into the base table of that view.
Okay, got you.
Okay, right. So we with expressions. So we're going to do the insert update. Insert and update is not possible. Any expressions are there at the time, you can't perform the update and insert operations. Understood? In expressions, expression is nothing but you're going to perform the any addition, subtraction, delete those things. You can't perform the these things. Okay, suppose now select, okay, sal plus commission. So this is going to total salary from EMP table. Okay, so this is the one it is coming. Why it is nothing is coming? 14 rows. Okay, sal plus commission, right? You know, right? Why this nulls is coming?
Because no commission is there.
Right, NVL of you can going to put it 0. Okay, so now if you are going to creating a view in this query, so you can't perform the insert and update statements in this view. Where we're going to insert the data into that? Got it right?
Uh-huh.
No, man. See, try to see here. You are going to. What does this mean by? You can read this once.
View with the expression insert update not possible, delete is possible.
So, what do you understand now?
You cannot insert or update the values with the expression like sal plus commission expression
Right,
is there, right?
right.
Like
Exactly.
that kind of use are there means you cannot do that.
Right,
Delete alone you can do it.
right. So now we with functions. Functions means some average, okay, and upper or lower or these things. Whenever you are using functions, you can't insert and update. Understood?
Okay.
So view was created, but the underlying table was dropped. We will get the message like view has error. So suppose now, see, I created a view. Suppose now, where is the student table? This is the student table, right? So now, suppose now I'm going to create the table. Sorry, create a view name. Create a view name, student, student underscore v as cell star from this. See, view created, right? Yes or no?
Yes.
Okay. So now what I will going to do, cell star from view. Okay, the student underscore view. You got the data. So I am going to drop this table. Drop table name. Student table, I dropped it. Now VV is going to work. VV is going to work or not.
Will not work. Once you drop, how it will work?
I am not going to drop the view, right?
But you are dropping the base table, right? Based on
Right,
the base table only, view is working.
right, correct. So now I will going to see. See now, you understand the error, right?
Yes.
So now next moving on to the next one.
Okay.
Can you read this one?
View was created, but the base table has been altered. But still the view was with the initial definition. We have to replace the view to affect the changes.
So
They're saying like base table is the update or delete or some changes happen. View will not be done changes,
no,
right?
you are not understanding. Read it again.
Was created at the base table has been altered, but still the view was the initial definition. We have to replace the view to affect the changes. That's what
Oh,
view is created based on
okay,
the base table.
okay.
If the base table you have any changes, view
What
will not
changes? What changes?
update, delete, insert.
Again, you are not understanding. Read it again. See, this word you are missing. Why you are going to
Oh,
telling about?
altered. Altered means update DML, right?
No, madam. Hello. Altered means see always in the
The
first.
structure you mean?
Yes, the table structure is going to change.
Oh, okay. The size and all that.
Okay.
Adding columns, deleting columns.
Okay. Okay. Right. Now you are clear, right?
Yes.
See, suppose you are going to created a view using some table. The table is
So
going.
I
Let's.
have one doubt. Altered means you structure is changed means you can delete a column, add a column. That also will be considered.
Not only altering the columns. I mean, you can going to add the columns, drop the columns, and modify
Okay.
the table, alter the table names or column names, and modify the size. These things. So these things, if you are going
Okay.
to creating a view using any one table, the table you are going to changing again. Okay. That
Okay.
is not going to affected into your view. Instead of, you should have to change it.
Make the changes in the view.
Yes.
Okay.
Okay.
Complex view. Yeah. View with more than one table. Insert
Okay.
not possible. Update, delete possible, not always. Okay.
Okay. So right. Let's. Can you read again next one?
Yeah. Complex view. View with more than one table. Insert not possible. Update, delete possible, not always.
That means.
If a view has like 2 or 3 tables together, that is called a complex view. When you cannot insert anything to one the view, because if you insert the view, you have to change in all the tables. So that's what they say.
So you understand,
Update,
right?
delete also at times only it is possible.
Okay. Okay. Understand, right? More than one
Yeah.
table is you are going to using. Where you will going to insert the data? Which table you will going to insert the data?
Uh-huh.
So now moving. So views you are going to clear, right?
Yeah.
Okay. Views with the check option constraints you can going to do. Okay. See this. Create a view name with the where condition, check condition you can going to use. So if you are going to use in check constraints, so insert update is not possible, excluding the column name. Delete is possible always. Okay.
Okay.
So next views. So how to remove the views from the database? Drop view name.
Okay.
Permanently it is going to dropping the table. Okay.
Okay.
So you can going to see all the views and DBIUs and user views. In the database, suppose you want to see all the views, you can going to query all views. So this is the one. Excuse me.
Hello. Hello.
Yes, Mansa, yeah, please.
Yeah. Okay.
So you can going to see all the views into that table, all underscore views. Okay. So DBI views you can see in the below table, user views you can going to see in the above table. Okay. This is so this is going to Oracle tables. So you will going to get it to maximum all views. See, all objects is one table is there. In that table you will going to see each and every view there. Okay, all underscore objects.
Okay.
All objects where object type should be going to view. Type equal to view. Okay, so you're going to get all the views. Got it. Now moving on
Yes.
to, so now views. So you understand, right? So
Uh-huh.
which situation you're going to create a views and what are the limitations you have and what operations you can perform, what operations you can't perform. Okay, right. So now moving on to the
We did
synonym.
not do views with check option constraint.
What do you want on that? See, already I show you, right? This is the one. Same. See, what is the query you performed before?
Okay.
See, already you know these all SQL queries. So just simply you are going to adding instead of create view table view name as that is the what. So remaining all things already was in previous classes.
Okay.
Understood, right? So if you are not
Yeah.
understand, let me. I will going to explain again. See,
Okay.
this check constraint already you done before. Yes or no?
Uh-huh. Yes.
marks equal to 500 with check option. So check option, the constraint name. This is the what we done. So what will happen in this view? Insert is possible. You can going to insert the data based on that condition. If the condition is false, you can't perform the insert option. And update also possible whenever the condition is matches. And delete is normally possible.
Okay.
Okay, so that is the what. So if you want to delete the permanent views, you can drop view name. So all views you will going to see all objects table level. Okay. Next, moving on to the sequences, synonyms and sequences. So synonyms and sequences, synonym is nothing but just it is going to snap up the table name. Understood. Just a duplicate name. A synonym is a database object which is used an alias of the table or a view or a sequence. Okay. What do you mean by the synonym?
It's a duplicate name for the
Table,
table.
view, and sequence.
Okay.
Got it? So table name
Huh?
and sequence. Table and view and sequence. Okay. You can create a synonyms for the tables, views, sequences. And not only the table and view and sequences, you can going to create a synonym for the procedures, packages, triggers, okay, and functions. These all you can going to do it. Understood? Sir,
Okay.
why you need to create a synonym if it is already table is there? Yes, right? Yes or no?
Yes.
So if it is already there, why you want to create? So now what will happen in Oracle database, we have multiple instances. See, suppose this is called as a one instance. What is this instance name?
What?
What is this instance name? Instance name
A
means this
apps
apps
at
is a
BIS.
user. Instance name is WIS.
BIS.
Okay, so WIS like this we have multiple. Now one more instance is there here. HR. See now, WIS both are WIS only. Database name WIS only. Whenever you have multiple instances, okay. So in that case, what you will going to do? See now, see everywhere how the instances is available means databases. They have multiple databases. I will going to explain you. See, we have instance is nothing but a collection of objects,
Okay.
database objects. Instance is nothing but collection of
Multiple
data
objects.
database objects. So object is nothing but anything like a table or a view or a synonym or a sequence or a index, whatever it is, we can call it as the object. So every company, what they will going to do, they will going to the production instance. Production instance. So this means real data it will be available. Real time data and users are going to using okay. And then you have UAT, user accept testing, UAT and SIT, system integration testing, and development, dev, dev instance. Understood? So we have like this WIS. However, we have a here WIS instance. In the real time, you will going to see dev instance, UAT and SIT instance and a production instance. Okay, total 4 or 5 instances is available. Okay, sir, why we need this number of instances means in the production instance you will not going to do any your development work. Understood?
Only read only. Yeah.
Say probably they will not going to give for the access for the developers first of all.
Okay.
Understood? Only users they have and supporting team they have this access. Understood? So this production instance means so who will going to using the application in the real time operations. Every day running operations they are going to doing there in the production instance. Okay, understand until? Hello?
Yes. Yes.
Right. Now you are a developer. So you joined as a developer. So in the joining day, what they are going to doing, they are giving some work to you to do the creating tables, views, and as well as some queries. You should have to prepare that. So where you will
Okay.
going to prepare those queries and creating tables and views and all? Are you going to doing UAT and SIT and production?
No, development.
So you should have to perform into development. So once you perform in the developments, okay, done. Later, you need to give that code to, you should have to move the code into production, right?
Yes.
Yes or no?
Yes. So you'll
Uh,
do it in QA.
First, you will going to do the test into UAT, user accept testing. Before going to user is accepting, we will going to do the testing
QA.
in UAT. So that means, how did you move your code into UAT? You got me right? How did you move into your code into UAT or production? So you will not going to create a direct tables into that again. You can going to create a synonym and
Mm-hmm.
you will going to give the grant access to that people.
Okay.
Understood, right? Now you understand why the synonym is required. Synonym you will going to create on top of the table. Thus, synonym you will give the access to the multiple users. I mean, multiple instances you can going to give the access.
Okay.
Okay, right. So this is the what it is going to happening. Let's so now we have two type of synonym: public synonym, private synonym. Private synonym is available to particular user who creates. Say private means
Mm-hmm.
you can't create, you can't give the access to the other users. Understood? Only you can able to use that synonym. Public synonym means you can going to give the grant access to anyone, all the users. Okay.
Okay.
So and next you're going to see advantages of this synonym is going to hide the name of the owner of the object. To see every object you have a owner. So you can see here who is the owner? Sisu. What is the object name? This is understood. So
Uh-huh.
you can going to see the you will going to hide the synonyms here. See here. Owner you can see, object name you can see, object type you can see. Right? So let's show you some sequences also. You can going to put it here. So suppose in the views you will going to put the sequence, you will going to get the sequences of that particular. 1 second. See that number of sequences we have.
Mm-hmm.
Now in the sequences, what we can going to do, see suppose, see these all are standard sequences, okay, that Oracle provided sequences, okay. So you can create your own sequence and you can, synonym, you can create your own synonym and you can going to apply that. Let's going to show you some synonyms. So see, create synonym S1 for empty table. So you will going to create a synonym for that particular. 1 second. So, excuse me. Right. So now how we will going to do? See, create synonym name for EMP table. So what you're going to do?
Create synonym
name for EMP table.
Okay.
So now you created a synonym for EMP table. Now you can query the synonym also here. Cell star from S1. See, data is coming, right? Hello.
Yes, but
So one more is you can going to create public synonym S2 for EMP. Yeah, you can create that public also. So here you
okay.
can going to see the public also. Sorry, S2. See data you can able to. But this is not going to helping you in the your real work. Okay. So key. I don't have a multiple instances to show it to you how it will going to grant to the different users. Okay. So
Okay.
let's see 1 second. If I try to log in into HR, is it possible or not? Let me connect. If it is connecting, then we'll try. Okay, it's a good to see this now. Okay. So now I created a synonym, right? Let's go and ran this into HR. If I ran here, is it able to know? See, insufficient privileges. Insufficient privileges is there. So
Okay.
table or view does not exist, but S2 is going to insufficient privileges. Now you should have to give the grant access to that to HR. The grant and the revoke is there, right? So you're going to see some. Last time I told, so I will going to teach you when we are going to discussing this grant, the grant and revoke. Okay. So now grant and revoke is going to see DML commands are used to granting or revoking the permissions. So grant means you are going to giving the permission to the other person. So grant privilege on object name to object name. Okay, this is the what the syntax. So revoke means you are taking the permission back to the whatever you are giving. Now you can tell me grant privilege. Privileges means insert, update, delete. So I am going to putting grant all on object name. What is the object name? Yes to right. Hello.
Yes.
Yes to name. What is the user?
User is
HR.
HR.
Yeah. With the grant option. What do you want to give the option? Grant. No, I don't want any option. All I am going to giving.
Okay.
Insert, update, delete. You can going to do. See,
Okay.
grant succeeded. You can see down. Grant succeeded. Right now, go to HR user. Let's see. See now the data you are able to see.
Yes.
Did you create a table? S2 table here.
No, we created.
See now, 1 second. We are not going to create anything here, right? In yeah, HR.
Yeah.
Okay. Now let's see. What is the table? EMP table is there here? No, right? Okay. So now EMP underscore some S I am going to put it. So this table is not available. So what I will going to do? I will going to create a public synonym for this. Okay, let's create it. Create public synonym. Okay. EMP underscore S. public synonym emp underscore yes for emp table. So I created a emp table. Now I am going to checking here emp underscore yes. See, data is coming here. How this data is coming? Already you are giving the grant access. So you can see here emp underscore yes. So emp. So here it is. Grant all to S2. 1 second. We should have to give this access actually. Uh, so now you are clear, or you want one more example?
One more example.
So okay, let's see this. Select star from DEPT. Okay. This
Okay.
table or view does not exist. Yes or no? Okay. Suppose now I am going to putting yes. So table or view does not exist. I am going to creating a synonym on department table. Okay.
Okay.
Now create or replay create a public synonym DEPT underscore yes. DEPT underscore yes for DEPT table. Okay. So synonym created. Now go and run this table. What is this is? Hello.
Hello.
Yeah, what is that is? Error.
Insufficient privilege. Maybe you do not have grant.
Yes. So you should have now synonym public synonym is created, but grant is not done. So you can going to give the grant. You can going to give the grant for only insert, select, update, or delete, whatever it is. If you put all, then all will come. All on DP underscore yes or HR user. Sorry, two you should have to put. Okay. Now your grant is succeeded. So you can go and check there.
I think this is enough for today. It's okay.
Okay. So it will going to done that is. So now this is going to synonyms. So revoke means just you will going to taking back of that. Revoke. See, just try to finish this only this example.
Okay.
Revoke privileges. Just I'm going to taking back of all privileges. Okay. All. Not into HR. So where should I have to take back? You should have to take the back from the WIS instance, right? This is WIS user.
Yes.
Okay. So what is the object name? DEPT underscore yes. DEPT underscore yes. What is the username? HR. Okay.
Okay.
All right. Can you see below?
Revoke succeed.
Now go and execute this. DEPT underscore yes. What is this again?
Insufficient privileges means grant access is not there for that table.
We are taking back, right? Okay. We are taking back, right? Access we are giving. After that, we feel it, we no need to give. Again, we are taking back the access. So that means whenever it is required, you can give the access. Whenever you are required, you can take it back.
Okay.
Okay. Right. So shall I stop now?
Yes.
Okay. Right. So try to practice it. Okay. So you will going to understand.
Can I have video of yesterday's and today's?
Yeah, I will do that. Okay, 1 second. So indexes. So index is typically a listing of words accomplished by the location of the information on a subject. See, you are going to creating a table. The table is going to stored into the database as well as the table space also allocated. If you are going to create a sample table EMP, right? This is the table created where this data is going to stored. The database it is going to stored. Here you can see lots of table properties you're going to see here. Columns. What are the columns available in the table? Okay. Constraints. What are the constraints is available on the table? Okay. Triggers. If it is any triggers are created, the triggers are there. Okay. Data. What is the data we are inserted into the table? Script. Script means what is the table script is created. I mean, create table script is there, right? That's the table script you are going to see here. So here already table is there. You are inserted the data. See now. So you will going to see the table space, right? Down you can see the table space. So this table space is so initially they are going to allocate 128K of data initially data. Okay. So this data, the table space is going to allocated for every table. See, you can going to see this table data and all. Now, this table data, it will see now while going to inserting the data is going to stored in this table space only. Okay. So here you will going to see remaining so many things. So indexes, you can see if it is any index is created, you will going to see here. pk underscore emp index is already created one index. Okay. So primary key column also it is going to working like as an index only. Okay, keep in mind that. The indexes are most useful on large tables, columns that are likely to appear where the clause has simple equality. That means, so how it will going to working these indexes means, now table is there, the table data is there. Okay, why we need to introduce into the index? That is the question now. Understood?
No, can you repeat that?
See, some tables you created, the data is going to inserted into the tables. Now you are going to applying the index into that particular table level, columns level. Okay, in the columns level only, table columns level, we're going to create the indexes. So are you clear where we are going to creating?
Yes.
Okay, why we need to create the index? Okay, indexes typically a listing of keywords accompanied by the location of the information of the subject. So that means column level, if you are going to creating an index, that means it is Oracle database backend. It is going to automatically, it will going to allocate some memory for this data. Understood? So in that memory allocation level, other things will not come and it will not allocate to others. Only it will going to allocate some space to this table columns and as well as table data. Got me? So it will going to help to speed up this SQL queries. Once you created the indexes, automatically it will going to see normally whenever you are going to see, suppose 10 items, you are 10 different items you are going to keep into one place in one room. So how you are going to keeping, there is no serial you are not putting, zigzag you are going to like that you are throwing. Okay, suppose some particular item you want, are you going to take it directly? Hello.
Uh-huh.
See, madam, say suppose one that garbage room is there. So in that storage room, you are going to kept like this so many items. Okay. So you are not going to keeping the items into some parallelly or some sequentially, some proper format. You are not putting like that. So everything
Okay.
you are going to keeping like that, like that. So all the things are like look like a zigzag. It is there. Okay. Now you need a some item. How you will going to take it? You will going to take directly, or you are going to searching one by one, and you are taking it what you want.
Search by one and take it.
Right. So search by one means it will take time, or it will take immediately.
It will take time.
Like that. So whenever we create a table in the data Oracle database, we have the storage space is available. So at the time in database, we are going to creating hundreds and thousands of tables, right? So thousands of tables data is going to stored, but it is not allocated. The data is allocated, but it is not going to give the point of space. Understood?
Mm-hmm.
So that is common memory is going to allocated for all the tables. Understood? So
Mm-hmm.
at that time, Oracle, you are going to searching your query. So what will happen? It is going to the search engine is going to backend. Okay, SQL search engine will go to backend, and it is going to searching for where is our data is going to stored in the overall database. Understood?
Mm-hmm.
So now if you are going to using index, so the search engine particularly it knows, okay, this is going to stored in specific place. So directly it is not going to searching in the overall database. So directly it will go on to that particular point of space and it will going to picking the data. So that means what will happen? Query performance is going to increase. Yes or no?
Yes.
So that is the main use of the indexes. If you are
Okay.
using index means only single line, what you will going to give the answer?
Performance.
It is going to increasing the SQL query performance. Execution performance is increased. Okay,
Okay. Okay.
right. So we have different type of indexes here. Okay, so you can see here so many type of indexes are there. See now, the index points directly to the location of the rows containing the values. Clear?
Mm-hmm.
That is the what I'm explaining. Now, so see in the similar kind of in your room, you are going to putting the things into everything in the proper format is serially and sequentially you are putting. So you know where they are, whatever the item you are looking. So you no need to search it into all the items. So directly you will go that item and you will take it. So lot of time is going to saving in that time. So the similar kind here also index is going to allocating specific point of place that unallocated memory. So this all the data is going to stored into that place. So it will going to picking the query very fast. Now you can see here unique indexes, non-unique indexes, B-tree indexes, bitmap indexes, composite indexes, reverse key indexes. We have so many indexes. Okay, most of the 90% of the indexes we are going to using unique index. Okay, keep
Okay.
on mind that. So we have keep on mind we have so many type of indexes. Okay, but we are going to
Okay.
using most of the cases into unique indexes. Okay. Now coming into unique index is nothing but it is going to okay. So it is uniquely like primary key. Whenever you are going to using see unique index is automatically created when primary key or unique constraint is created. Clear?
Mm-hmm.
You are not going to specifically creating the index. So whenever you are created a primary key or any key constraint on specific table, so automatically it will going to the key index is going to create it. Clear?
Yes.
Okay. And And you can going to create into your own index using index keyword also. You can create unique index student ind index on table and column name. Got it? So this is the
Yes.
syntax of that. Create unique index, name of the index on table column. Now tell me, madam, your unique constraint and unique index is created on which table, what column? Student table,
On
serial
students
number.
table, SN column,
Yes,
serial
and
number column.
student number column, we are going to create the index. Now, one more thing you can tell me, without using index keyword, how to create a unique index?
By unique key constraint.
Right. Whenever you are using the primary key or a unique constraint used at that time, automatically index is going to create it. Understood?
Uh-huh.
Right. So move on to the next one. So non-unique. Non-unique means same thing. So non-unique index is do not impose the above restrictions on the column. So that means it's just vice versa of the unique. Understood?
Mm-hmm.
So non-unique means you can able to insert the duplicate data, you can insert the null data. Okay,
Mm-hmm.
all you can going to do, and then so B tree indexes and ascending indexes. These all type of indexes only. Okay, so
Mm-hmm.
we are going to using very less time, maximum 99%. We are going to avoiding these remaining all indexes. Okay.
Okay.
Only we are 90% of indexes we created only primary that first one unique index only will going to doing. Okay.
Okay.
And one more thing you can keep on mind, this is going to cost effective also. It will going to affect. Oracle will not going to give all indexes at free of cost.
Okay.
These remaining indexes, if you want to implement into your code level, okay, you should have to take the approval from your manager as well as the DBA people also. Got it?
I did not understand last part. We have to
See,
get
suppose if you want to implement B-tree index or bitmap index, okay,
okay.
you
Okay.
should have to inform to your manager as well as some DBA people. The reason
Okay.
is Oracle will not going to support without cost effective on this. So Oracle will going to charge this cluster indexes. See now, here cluster index is there, right? You can see this
Uh-huh.
here.
Yeah.
These all indexes is cost effective. So Oracle will not going to give the free of cost to implement these all the indexes.
Okay.
Clear, right?
Yeah.
So that is the reason most of the people are going to avoiding these indexes. So they are going to using most of the case primary that unique index. So unique index people are going to implementing. Okay, fine.
Okay. Yeah.
So don't waste this all the time to creating and learning these all the things. Okay, just what is indexes and how to create a that unique index, non-unique indexes, and how it will going to helping to the SQL query. You can going to look at those things. So that's enough.
Okay.
Okay, and then so here we can see so many theoretical as well as remaining explanations are there. One second, constraints I will show you. Again, no, okay. Where is that functionality? One second. If they are going to using in anywhere into, suppose did you use the indexes, they ask in interview questions, what you can say? Yes, I used it. in my queries. So what type of indexes you used? If they are asking, you can tell it. Most of the places we are going to using unique index.
Okay.
Got it right? Unique indexes we are using. If they are asking why did you going to use the unique index, you can tell it. So due to SQL query performance, we are going to using the unique indexes and we implemented. And after that, my queries are going to increasing the performance. It's improving the performance of your execution. You can tell. Okay, right. So let's move on to where is these partitions. One second. Right. So now we are coming into partitions. So this is also a very important concept. But as per see, this is the depends on your client, madam. Suppose you are going into banking sector, okay?
Mm-hmm.
You will going to use most of the cases partitions. If you are going into manufacturing clients, very less manufacturing or any other domains, very less of time you will going to using these partitions. So partition is nothing but a single logical table can be split into number of physical separate places. Understood? Now suppose now banking data is there. Now in the banking data, so how we will going to implement banking data? So partitions is going to helping you are dividing the work into different tables, like a big table is there. Suppose now historical banking accounts information data. Now if in India you can take it as a suppose SBI, how many users are there? Maybe in and around
I
minimum
don't know.
minimum more than 2 crores of users for them, 2 crores records, right?
Okay.
So now 2 crores records, are you able to analyze it?
No.
So you can analyze it. Is it easy in a single table?
No.
So that is the reason in the single table they are going to create, they are going to partition into different tables in a single table. The original table is like that only. You will going to dividing the partitions, you are going to dividing. See, suppose a big work is there. If you are going to taking a big work, are you able to do it? No, right?
Yes.
So what you will going to do? You will going to dividing the work into partitions, pieces. You will going to divide, and you will going to start on one by one. All the things you will going to finish it, right?
Yeah.
So in the similar kind, so in SQL also we have some historical data information. It is available. Suppose if you go into historical, crores of records will be available. Understood?
Mm-hmm.
That data you can't analyze it into easily. So how we will going to analyze it? You will going to divide the biggest that SQL table data into number of partitions. You can going to split to see this. A single logical table can be split into number of physical separate pieces based on the range of key values. Each of the parts of the table is called as a partition. A non-partition table cannot be partitioned later. Okay, so it is not possible. Non-partition table. Now, so how we will going to divide the data into partitions? We have four type of partitions is available: range partitions, list partitions, hash partitions, sub partitions. So Oracle provided four type of partitions: range, list, hash, sub partitions. Understood. So now, can you please read these advantages, madam?
Reducing downtime for scheduled maintenance, which allows maintenance operations to be carried out on a selected partitions, while other partitions are available users.
Right, right. So what you understand now?
Maintenance which allows maintenance operation to be carried out on a selected. Okay, it help if you are doing partition. Main schedule, you're going to schedule a time for doing that, and the main one will be in maintenance and others will be available for the users.
Right, exactly. Right. Sri, suppose you are going to do, starting as is, now you can going to see some any banking websites. So sometimes few of the users are able to log in and they can do their operations. Few of the users is saying under maintenance, it is available on couple of hours. It will come the message. Yes or no?
Yes.
How they will going to see? Some people they are able to do, some people may not. How they are going to dividing the system like that way based on this only. Understood?
Okay. Uh-huh.
Now the table data is crores of data is there. Some maintenance is going on. You are going to locking the table. Is people are going to able to see operate that? No, right?
No.
So that is the reason we are going to dividing the data into number of partitions. So the partitions is going to all partitions you will going to work on only specific partition. Remaining partitions are going to available to the users. Okay.
Yeah.
Next, reducing the downtime.
Downtime due to data failure. Failure of a particular partition will no way affect other partitions.
Understood.
One is not working, others will not. It will function.
Right, right. So that is means so you no need to worry about remaining all the partitions. Only whatever it is causing the data issue, that partition will going to put on downtime and will going to fix the issues. Okay.
Uh-huh.
So now next partitions.
Partition independence allows for concurrent use of the various partition for various purpose.
So what do you understand? You can going to independently going to do the operations and you can going to divide that what purpose we are going to using each and every partition you can going to use like that way. So different purposes, different partitions you will going to create and independently all it will going to work. Okay. Right. So now advantages of the partition by storing them different table spaces. Understood. Reduce the possibility of data corruption in multiple partitions. What is going to advantage? It's going to corrupting the data is going to reduce it. The reason is you are going to dividing the data into multiple partitions. Backup and recovery of each partition can be done independently. So easily you can take the backup also. Understood? Backup means so you should have to take every day backup data, right? Whatever the data is going to store, you should have to take the backup. Why the backup is required? Whenever
Because
if it is right, so if it is anything is happened at the time, backup data is going to helping. Now suppose backup recovery you want to do, suppose only one table it is there, the table having crores of data. Are you able to take the backup fast?
No.
No. So while going to taking the backup, something is happened. Whatever you took the backup, that also it is gone. So that is the reason partitions will going to independently will going to take the backup from each and every partition level. So disadvantages. So partition table cannot be contain any columns with long row data types, lob data types, or object types. Lob data types you can't use into the partitions level. That means you can't store the data into the like videos or some any big images or a big some suppose text files, word files. These things you can't going to store into the database.
Okay.
Understood?
Mm-hmm.
Long raw data types means so you can't store the videos or text files or Word documents or any video clips, audio clips. These things you can't store. Clear?
Mm-hmm.
Disadvantage is clear, right?
Yes.
Okay. Now going into range partition. So range partition is this is going to helping you to create the range. Let's create a table and do the range. Okay. And one more, this is also you need to get the permission from the Oracle license you need to buy. Keep on mind. Partitions also you need to get the permission license from the Oracle. Otherwise, you buy Oracle product, you can't going to get it directly. You want to implement this, you need to get the license from the Oracle, then only you can going to implement this. So this is the reason. So only banking sector people, most banking, insurance, these financial related sectors, they are going to implementing these partitions most of the classes. Okay. Other domains, very less people will going to implement it because cost involved. This is right. Create a table. Table name is a student. Okay, student number, name, and partition by the range. Now you are going to partition by what column?
The range.
Range of number. Partition type is range. On your what column you are doing the partition? Number. Understood?
Okay.
And partition P1 values less than 10 and partition P2 values less than 20. Now, how many partitions I am dividing now? You can see here. P1, P2, P3, P4. Yes or no? So, how many partitions I am dividing?
4.
4 partitions I am dividing. I am going to giving the range also. While creating the table itself, I am going to dividing the range. Now, whatever the data I'm going to inserting now, so this is done, right? So it is going to excuse me. Right. So now you can tell me here if I'm going to creating this table while going to inserting the data. So excuse me. Right. The table is created, madam. Okay. What is the table? Student. So you can see the data student. Now suppose I'm inserting the data student number 5. Where it will go?
Where?
Suppose now I'm inserting the data into the tables. Okay, only the number and name, student number. Number is going to 5. Okay, name is going to Kodeshwar. So in which range it will go? 5, number 5.
There is no number 5 partition, right? How it will go to 5?
I am talking about I am inserting the student number 5.
Oh, okay.
Where it will go? Okay, let me try to insert the data into the table. So don't think it is a big all complex things we are doing. We are doing very basic and understanding purpose we are doing now. Okay.
Okay.
So why once you understand basics how to do these things, then only you can able to implement into your regular work and what the client they will going to give that work you can able to do it. Now, okay. Now inserting the data into the range table. Now let's 1 second. So now here we can see. Now first one I am inserting, madam. Okay, number is going to number one, and it is going to name is going to A. One row is inserted. Second row also inserted. Okay. Third row also inserted. So fourth row also inserted. Total 4 rows are we are inserted. Now we are queried into data. Now we are able to see the data into 4 records in the table, right? Yes or no?
Yes.
Okay. Now how you will going to see the data into the partition basis? How you will going to see the data into the partition? So P1 partition how to see, P2 partition how to see. Okay, select star from table name partition 1. Now you can go and see the partition 1 data. See, you divided 4 partitions, right?
Yeah.
Select star from student, okay, partition P1. So now see, P1 only 1 record is going to stored. Yes or no? Now suppose I am going to putting 9 and here it is going to X. Which partition it is going to store now this record? Hello?
Uh-huh.
Which partition it will? Huh?
It will show on.
If this record, if I inserted, where it will going to store? Which partition level it will going to store?
1.
Why 1?
Because the student value 9 and X.
Why it is 9x means it will go to 1. How did you say that?
Because the range, it is 1 and A.
No, madam. Here it is. I am putting 9 comma x. Okay, I will going to put Koteshwar. So what will happen if I put suppose Kevo? How did you going to say this? It is going to store into P1 partition. Madam, read this, madam. Once so partition 1 condition. What is the condition? Partition 1.
Less than 10.
Right. Whenever less than 10 number is there, then it will go to P1. Understood?
Okay. Uh-huh.
Now you can see why it is coming. So I inserted below 9 it is all. Same partition P2, P3, P4 like that you will going to see. People are going to inserting like this way data. So you can going to divide the partition and you will going to see the partitions into the similar kind.
Okay.
Got it now?
Yeah.
So while who are going to inserting, those people don't know what the partition is happening, how it is going to working and all. Simply they will going to insert the data into the tables. So you can going to divide who are going to analyzing the data. Now are you clear this?
Yes.
Okay, perfect. So what type of this partition? Range partition. Okay.
Range partition.
Yeah. You can add these columns, you can drop, truncate, rename, split, move, exchange. These all the things you can going to do it into your partitions again. Possible operations with the range partition, you can add it, alter. See this, alter table name, add partition P5. That means you will going to add more partitions into the table also.
Okay.
Understood. Now already you created a table with partitions. So now you feel it as a you want to divide the work into more partitions. So how you will going to do? You no need to touch the table structure. Simply you can going to use the alter table name, add partition, p5 values less than 40. So some partitions you will feel it is not required. You can alter a table name, drop partition p4. You can drop it. You can going to rename the partition one also. Alter table name, range partition, p3 to p6. That means whatever the p3 is there, we are going to renaming into p6. So truncate. Truncate means permanently you can going to remove the data on a specific partition also. Understood?
Okay.
So you can split that partition. You can exchange the partition. So this moving the partition. That means the space you are going to moving one partition to another partitions. Okay. So are you clear? Shall I move into the next partition?
Yeah. Can we do it tomorrow?
What happened, madam? Okay, fine. So look at, so tomorrow we're going to see these partitions and then
Okay.
uh, global temporary tables and analytical functions. So only these things are pending now.
Okay.
Okay. So we're going to finish it this at least this Saturday and Sunday, and Monday onwards we'll start on PL SQL.
Okay.
Okay. Right, madam.
Thank you.
So partitions all are going to dividing the data into different type of partitions. So the data will going to stored in tables that specific areas. So when you are going to calling the data, so it will going to pick that specific path in that it is going to picking. Okay. Now here it is range partition means you will going to divide the work into different ranges. So see, suppose 1 to 10 is one range, or 11 to 20, 21 is the one range, or 22 to 32 is one range. Like that you can going to give the ranges. The whenever you are saving the data, based on that range, the data is going to storing into the tables. Now coming into hash partitions, this is also a type of a partition. So how this is going to storing the data and how we are going to using, we're going to see now. So hash partition, so you can going to create a table using hash, using the hash symbol instead of range. So you're going to divide the data into different type of hashes. Let's see. Say maximum 90% of you can't going to using these things. So first of all, this is a licensed version. Okay, maximum companies will not going to get this licenses. Only few of any hospital related clients or any uh, I mean banking related clients only will going to get this licenses. Okay. So create table name. Just we are going to creating a student table, the number and name, the partition by hash with number. So how many partitions we done? 5 partitions. Partitions of 5 we can going to do. Now, so suppose I'm going to using student 1, 2. So table created. Now you can going to, now sys P1, sys P2, sys P3, P4, P5. These are the partitions. Partitions automatically divided now. If you are going to putting partitions 10, automatically 10 partitions will come. Okay. Now we will try to insert the data into that partitions tables. So let's see. So based on the partition key, the data is going to inserted into the tables. Now you can see here insert into table name. So here you can see student 1, 2. So while going to query this, now how did you going to query this table, madam? Shall start from student 1 2. That's fine. So how we will going to see the partition wise data? Sorry. See now, some data is there. Okay, it is going to stored. Now how we will going to get the partition wise data? So now what we can do here, shall start from table name partition P1, P2, P3, P4, like that we can going to get the data into the partitions. So how system is going to knowing this sys P1 automatically created these partitions. So if you going to give the here range you are giving, right, partitions of 5 hash partition, partition by the hash of number means in this student column number. So now you are going to giving number 5. So number 5 means automatically it will going to take this partition 5. Now select star from table name partition sys p1 specified does not exist. 1 second. We'll see the partition here. Go to F4 and here we can see the partitions. See now. So here partition numbers are going to created into different way. So this is going to 542 57 it is going to created. So these are the partitions that is going to created. So automatically these partitions are divided. See now in this partition, so data is going to 2 records are going to stored. So in the similar way, you can going to see remaining all the partitions, 4 partitions you can see. Only you are going to specifying the how many partitions you want. So the partitions automatically it will going to created. Names automatically created. So here you can see. So 5 3 2 5 4 5 5 5. Mansa, you got this scenario?
Yes, I got it.
Okay, fine. So just to keep on mind how the things are going to working. When requirement comes, then you will going to work on. Okay, got it. So this is the way it will going to working. See, some partitions data is moved, some partitions data is not moved. That is depends on the here data range, how it will going to it's going to inserting the data. Understood? Let's move on. See here. So this partitions 5 you are giving, that is the reason 5 partitions automatically system is going to created for the hash. Okay. Now here that numbers we are entered, right? Based on that numbers only we'll going to inserting the data into the different partitions. Data is moved into different partitions. But that is how this data record is going to calculated based on taking that whatever the partition key is there, right? So here we have the partition key is automatically is coming. Sys P3 to 32453 is there, right? Based on this key only data is going to splitting. So how it is going to calculating internally, we want to check that. So how key is going to identifying what data should have to move into what partition. That is, we need to look it into backend how its system is working on that. So that is take care by automatically Oracle specified background programming. Okay. So shall I move on into another partition?
Yes.
Okay. So again, subpartitions, range partitions also we can create using the range and the hash partitions. Both we can do. So this is also looks like the same only. Can going to create it. See here what we can do. As of now, you use a range partition and a hash partition. Now again, you can going to use it in both the partitions. So just I will going to explain you the how we are going to create it. And this is very, see, while coming into partitions, how you are creating, how you are going to inserting the data, and how you are going to retrieving the data. These three are important. Okay. Right. So here we are going to creating a table using the student number, name, and marks. So partition by the range of number, and the sub partition by the hash number. Hash is going to using name. And again, partitions are going to 3, they are going to dividing. Partition P1 values less than 10 and P2 values is less than 20. Now what you understand, madam, in this case?
Creating a table called student
Okay.
with the range partition, you're doing it.
Range and as well as
Hash.
hash, both we are doing. Right. Range, how many ranges we are giving? P1 and P2. Okay. P1 is less than 10 values is, it will go to range partition P1. If it is below 20, 10 to 20, it is going to P2. And hash partition, how it is going to be working here again? Subpartition by hash based on the name. Understood? Student name is going to taking again hash partition level. So that is going to divide it into how many partitions?
How will you take student name?
Yeah, you can take it name also. Based on the name, it will going to divide the partitions. That is already I told, right? Hash partition, how the data is going to flowing, which partition and which partition, we need to understand in the background programming how it is going to working on. Okay, based on the name, they are going to divide it into 3 partitions again. Clear?
Yes.
Okay. So now, see now, say P1, P2 means range partitions. Under P1 again, 3 hash partitions will come. Under P2 again, 3 partitions will come. If you go into banking sector now, if they are going to asking, so asking range partition is every quarter, Q1, Q2, Q3, Q4. Understood? Again under Q1, suppose you want to split the into January, February, March. Understood now how we are doing?
Yes.
So now P1, P2, P3 is going to quarter of the year. So now subpartitions, hash partitions is going to month. Got it?
Yeah.
Okay, like that it will going to splitting the data. Now we'll going to insert the data and we'll going to see the data same way. Okay, and then next is going to, so hash partitions we done. These all the tables of that partitions. So one second now. Anything is missing in the partitions I'm looking on.
Okay.
So just keep on mind, suppose in interviews they will going to ask, do you work on partitions? If they said not exactly so, but I didn't get a more on this type of requirement. The reason is my client is saying that manufacturing or something, and you can tell about that. That is going to licensed version, so we are not exactly worked on. But I have a good knowledge and as well as a little bit experience on partitions, and tell this all the things how it will going to working, how we are dividing. Huh? Got it right?
Yes.
So that is the one. One second. Where we are in. Right. So now we want to see the list partition. So range partition done and hash partition we done, sub partitions we divided. Now we'll miss it range partition. Let's show you the list partition. See, the list partition also, it looks like you're going to create a list will going to give. In that list, the data is going to dividing into, inserting into the tables. Yeah, you can see, madam, here this. So create table name, partition by the list, right? Before that, partition by range, partition by hash, and partition by list now. So the list is going to taking as a number only again. Now partition P1 values, that means we are list P1 values belongs to 1, 2, 3, 4, 5. Partition P2 values belongs to 6 to 10. Partition P3 is going to 11 to 15. 4 is going to 16 to 20. Now, once we created this partition, let me create this ones. Okay, 3, 4. See, now table got created. Any questions on this table creation?
No.
Ask me if you have any questions. Okay, it's a really interesting concept. This is. So total, how many partitions we divided? List partitions. Total
3.
four.
Four.
Right. 4 partitions we divided. And what is this partition? List partition, right? So that means the list of values. So now you can see P1, what are the values, madam?
P1 is 1, 2, 3, 4, 5.
Right. Now when we are going to inserting the data into the table, student 3, 4 table, at the time student number is coming 4. So which partition it will go?
P1.
Right. Student number is coming 19. So which partition will go?
P4.
Right. So you got it right.
Yes.
So, but the thing is, based on these examples, you should have to implement into according to the client requirement. So now you know the concept and you know the examples, you know the syntaxes, right? So simply you will going to enable into your client work. Got it? See, suppose client is going to asking his requirement. What you can do? You need to think about which one is going to fit to his requirement. Is it range partition, or is it going to list partition, or hash partition, or sub partition? Which one is the best for them? So you can going to implement that. Clear?
Okay.
So they never going to ask to implement into list partition or sub partition or hash partition. Understood? Range partition. See, according to his work requirement, you can decide it into which one is the best suits for him. Got it right?
Yes.
Okay, perfect. So now you can going to. Now data is inserted. Now, how did you going to query this data now? So now this you can going to partition P1. Select star from table name. If you want to see the partition wise data, then you can going to use this data into P now. Partition P1. So select star from student 3, 4 table and partition P1. See, P1 means why it is going 1 now, number 1. So now if you go into partition P4, what are the records will come, madam? P4? Only one record will come. Got it? Now, so I try to insert the data into 22. Is it possible? Why I am unable to insert the data into 22 student number?
Because it's not there in the partition.
Right, is not there in the partition list. So now you understood, right? You can't going to insert beyond that range list. Okay.
Uh-huh.
So clear, right?
Yes.
Okay, so these are the partitions, madam. So you can go, first of all, keep on mind this part. If you want to implement partition, it's a licensed version. Okay. And then second one is based on their requirement, you can going to implement your partitions. Right. Okay. So now these are the tables you can going to see into the partitions in the backend table. Okay. So this group by having clause we already done, right?
Yes.
Okay, group by having classes we done already. Let's see what other things are missing for you. One second, I'm moving on into your demo session. See, as of now, this only global temporary tables is missing now. Okay, that I will going to teach now. One second. Na?
Okay.
Global temporary tables. So this is a global temporary tables. So when we are going to using and how we are using, I will going to explain you. Okay, keep on mind. This is also a very important concept only. Okay. So global temporary tables. That means the data will not going to store into these tables. Okay. First of all, keep on mind data will not going to store in these tables. Only just it is the one second. Let's open and I will explain you. Sorry, I didn't get this material. Already it is there in my system, but I need to look it once. Right. A temporary table is a table that holds the data only for the duration of the session or a transaction. Understood. Now, suppose you created a table, the data will not going to store permanently in this table. Only whenever the session is on, that time only it going to store. Once the session is end, automatically it is going to truncate the table. Session means, see, suppose now what I want to do, some data every day, some data is coming into the tables. Suppose today I'm going to doing all the transactions. I want to send this report to end of the day to my head. Head means, say, suppose some person is going to running a outlet business, suppose retail business is there. The retail business, what is going to doing? The end of the day, you want to see the total. Suppose you have 50 stores throughout all the cities. Now, end of the day, you want to see how much a transaction is going to happen. You want to see the report for which store, how much amount is coming, how much amount is spending, the overall store number, store name, store location, amount, how much amount is coming, how many customers are coming on that particular day into that particular store wise, and the total volume of that amount you want to see. Now, this data is coming into different tables. Yes or no? Hello?
Hello?
Yeah, Mansari following?
Yes, I'm following.
Yeah, now see, now the data is coming into different tables. What you did, you try to generate one SQL query for us. SQL query means you joined all the tables and you are going to try to pick the data into that particular table. Okay. Now the data is now query is ready. Query, you are running that query. You are getting the data. Understood. Now that data you are trying to generating a report, but But what will happen while you are going to generating the report, the data you want to insert into some another table. So at that time it is going to using the temporary tables. What will happen? What is the data SQL query it is giving? You are trying to and one more also is there. The same query you are going to using into multiple places. Understood?
Yes.
See, let me, I will explain you one more time. The requirement is, so some report query you need. Okay, you prepared a report query. The report query is ready. The query is going to fetching the data perfectly. There is no issue on that. The report query having total, suppose 300 lines code. Understood? Is a big SQL query, 300 lines query, SQL query. Now the same query you are going to using into some different requirement in different package you are using. Understood? Like that, the same query you are using into multiple places
Yes.
in multiple places you are going to using. Understood? So what will happen in this
Yeah.
case? In this case, how do you going to reduce this code? What we can going to implement in this case? Either you can going to use view, okay? Either you can going to
Uh-huh.
use into global temporary tables. If you are going to use views, what will happen? Again, storage space is required, okay? If you use the global temporary tables, what will happen? Whenever the session is open, the report, whenever the report you are running, at the time automatically the queries are fetching and it is moving the data into the table. From the table, report is generated. Once report is generated and you close it, then the data is going to truncated. I mean, it's going to remove the data from global temporary tables. Understood the requirement now?
Yes.
So that is, see, that is the meaning of this temporary tables. A temporary table is a table that holds the data only during the session or a transaction. Transaction means when you are going to doing the report you are generating, at that time the data is available. Once the report is generated, the data is going to removed, truncated. Okay. Oracle introduced a global temporary table concept since version 8i. So unlike temporary tables from the database products such as MySQL and SQL servers also we can use. So global temporary tables, Oracle permanent database objects and store data on disk variables. All session level only data is going to stored. Once session is over, the session is going to, it is going to remove the data. Okay. Let's see how it is going to create a global temporary table. Table name columns. You can going to on commit delete rows preserved. So this is the what it is going to helping. Once the data is going to removed, how it will going to remove the data. Let me. I think you are in confusion mode. Hello.
Yes. Maybe.
No, no. You will going to understand. Let's see. First, what you understand why we need the global temporary table, that you can help me. So I will going to help you more. So what you understand on global temporary tables?
Mm. When the
In which
data
in which
in
case we are going to using global temporary table, that you can help me otherwise.
when the data is huge,
Right. Okay.
like 300, as it told in the example, like 300 lines SQL.
Right. That is also one part. When not a data, whenever the SQL
I
query.
mean, sorry,
Uh,
SQL query is like 300 lines,
mm,
big query.
300 lines query and you are going to repeatedly using, okay, that is also one part. At that time what we'll going to use, will going to take a global temporary table, that query is going to fetching, suppose, sorry, I'm misleading, okay, sorry, give me a second. Whenever the data is going to fetching from the SQL query, it is coming huge data. Keep on data is going to increasing. Now suppose today I ran the report, I got a one report. Tomorrow also inserting the data again. So every day data is going to inserting into the tables and we are going to fetching data through the report. So, and once the report is generated, you no need the data to store into the tables. At that time, you can use into global temporary tables.
Okay.
Clear, right?
Yes.
Okay. So that means, see, keep on the transactions is going to happening, and once the report is generated, the data you don't want to store into the table. So at that time, you can take this global temporary table. So what will happen? Once the report is generated, it is going to deleting that data. Again, fresh data is coming every day. So this is called as the syntax of the global temporary table creation. Create global temporary table, table name, column definition, all the columns you can going to put on, commit, delete rows, reserve, preserve the rows. So what do you mean by this on commit and preserve by this? The syntax of the creating global temporary table and the permanent tables are the same exact the keyword of global temporary. So now this, whenever you are using global temporary keyword, that is called as a global temporary table. Okay, on commit delete rows. This is going to on commit means the class specifies whether the data table transaction is specified or session specific. The transaction specific or a session specific, you will going to mention here. So on clause on commit means uh, is it going to session based the table is going to committed or a transaction base is going to committed? See, what is the difference between a session based session specific and a transaction specific? Any idea? See, whenever we are going to inserting into this table data, we are going to inserting into these tables. Okay, so what will happen? Either you want to commit into each and every row, or else you want to session. Once the session is end, then automatically all the data is going to committed. Okay, is it clear, madam?
Yes.
See, now you created a global temporary table. The data is going to inserting into this table, and how you want to commit the data. Either you want to commit the data based on the each row, or else you want to commit on the complete session is going to end at the time you want to commit. So that is going to specify. On commit delete rows. On commit delete rows means this class specifies that the global temporary table transaction specific. It means Oracle truncates the table, removes all rows after each commit. Once on commit delete rows means once the record is committed, then it is going to truncate that record. Automatically, it is going to delete it. Permanently, it is going to remove from the table. Sir, if you are going to commit and deleting, what is the use of the table? Correct? Yes or no?
Yes. Yes.
The reason is, while once it is committed means automatically the data is sending into the report immediately. Once it is sending, immediately it is going to delete it again here. What purpose we are taking? Only we are going to storing temporarily. Global temporary table means only temporarily storing the data. Once the data is going to sending to the report, automatically it is going to delete it. Immediately it is going to delete it. On commit preserve rows. See, preserve rows and delete rows. So both are into vice versa. So this class specifies the global temporary table is a session specific. This is going to delete rows means transaction basis. Record row by row, it is going to commit and delete it. Preserve rows means the session based. All the session is going to, once session is end, the data is going to delete it completely. You got the difference, madam?
Okay.
See, here on commit delete rows is there. Okay. Whenever you are using on commit delete rows, that means once the record is going to inserted into the global temporary table, it is committed and it is going to delete the record. And on preserve rows is going to, that means it's not going to commit record by record. It is going to committed by whenever you are going to terminate the session. Now suppose this session I am terminated. I ended this session now. Session means once you open this database from the starting to ending, whatever you are doing, all the things, session time. That is. Now if you terminate this here, you cross it, the session is going to end. The session is end means pressure rows means global temporary table level, it is going to committed and terminated. Clear now?
Yes.
So on commit delete means record row by row. On commit preserve rows means session based. Okay. Right. So you can going to create a table here. See, you can create a table and you can insert the data and you can transaction table. You can see. Once let me, we're going to show you this example, madam. Okay. See, but this is going to the real time case we are using most of the cases. How? 1 second. Huh? So this is called as a table creation. Now you can see temp 1. What is this temp 1 data? I think previous classes we already used this. Okay, we're going to use into different tables. So now I created a table here. Can you try to look at this? So create
Sure.
global temporary table, table name, ID. ID means some student ID we are going to putting, any ID, description, on commit delete rows. So table created, global temporary table created. So next what we can do, now you are going to inserting the data into the table. Insert into temp11. So ID comma description values is a 1 comma transaction specific global temporary table. So this is now what will happen? Now we are going to inserting the data into this table. So one row is inserted, madam. Okay. So now we try to select that data and seeing the data. So you can going to see that temp11 you can going to see. Sorry. See, one record is inserted. Now you can going to that. Now you are going to commit. So if I commit, what will happen, madam? See, one record is there in the table. If I commit, what will happen? Hello? Hello? Hello?
Hello.
Yeah, if I commit, what will happen now?
If you commit,
See, table created on commit delete rows. If I commit, what will happen?
it will get created and it will delete the rows.
Yes, immediately you can't see the data now. See, there is no data. Understood?
Yes.
Now, if you use on preserve rows, on delete preserve rows here, even if you commit, data will not going to delete. Whenever the session is end, at that time data is going to delete. Clear now?
Yes.
Okay, fine. So let's, so this is the global temporary table. So now session specific also, see this preserved rows you can going to use. So you can going to simply, I will going to put that also. Okay. You want to see that preserved rows also? See, once commit is, the data will not go, only it will go for whenever you are going to terminating the session. So I put this URL also. So look it once this. Okay. So now what else it is pending in SQL level, madam? So as for one or two concepts I told, I will going to explain in the end of the sessions.
Yes.
So what are those? Any idea now?
Yes. Give me 1 minute. I will tell you. Dense rank concept.
Okay. And what else?
Underneath of dense rank, you left a lot. Differable, that dense rank from there.
Okay. Deferable I already explained.
Yeah. Differable you explained. Dense rank. Mm,
One second. I will try to explain you that dense rank one. See,
yeah.
dense rank and rank is going to, see, rank will going to give the results. See, suppose now you try to find the ranks. Now, whenever you are going to seeing the hundreds of people at that time, the same in the class having suppose ranks are coming. Rank 1 to 100 is there. Now, first rank is got to 2 people. Understood. Now, ranks, how you will going to define based on the marks, right?
Yes.
Okay. Now, what will happen in the class? They are going to getting 3 people are same marks is coming. You should have to give the for 3 people in the first rank only. Yes or no?
Yes.
But whenever you are going to using rank function, okay, the rank is going to giving as a 1, 2, 3, but rank will not going to taking care of how many marks is coming, but how it is going to taking based on the row id. Rank will going to decide that this all 1, 2, 3 ranks it will give, but dense rank is going to give based on, see, suppose 3 people are getting same marks, for 3 people it will give the rank 1 only. Understood? Understood. That
Yes.
is called as a dense rank. So now see, the dense rank is an analytical function. It calculates the rank of the row in ordered set of rows. The return rank is a integer starting with 1. So it's going to starting with 1 only. The ranks, it will going to give 1, 2, 3 like this. It will give. Suppose if you go into rank, what will happen? 1, but same marks is coming, but that same people it is going to give 1, 2, 3 in the rank. Dense rank is give it to 1, 1, 1, and then 2 will going to start. Okay, let's see some example and you will understand here. Right. So in this case, here we are going to taking some one column. So create a table name, and then we are try to insert the data into in the table. So we are going to let's 1 second, madam. I will going to show you clearly this example. 1 second. So I try to create a table using only column 1. So you can take it anything if you want column 1, or just for understanding I'm putting column 1. So table created. Now you try to insert the data into the table. Column values I am trying to inserting into what I'm going to do. A, B, C, D, like that we are going to giving. Now we are trying to insert the data into the table. So total 7 rows are going to 7 rows are going to inserted. Now if you can going to see what is the table name, dense rank demo. So now we can going to see the dense rank demo. See now some data, 7 rows are there. Now how did you going to give the rank to this? First AA, what is the rank will come? 1, B 2, CC, again 3 will come. Yes or no? D means again it will going to like that, it will going to give the rank. Now how we will going to see select? This is the query we have to use. Over dense rank over ordered by column number. So this is going to working how? Let's see this query, SQL query. Select column and then dense rank of over ordered by column. So column number. So now here we can put it as a rank, column rank. See now, same example, we can take it as a rank also. Instead of dense rank, we'll put it into rank. So what will happen? Now see, madam, even see rank is giving 1, 1, 2, 3, 4, 4, perfect. And 7 is going, right? D is 7 is coming. Yes or no? Hello? Hello? Are you able to follow me?
Yes.
See now, what is this one? Rank or dense rank? Excuse me. Yeah.
Yes, sir.
See now, A 1 1, B 3 is coming. Where is gone 2? Why it is not giving 2? See, madam, A means it's the same marks. That is the reason rank A is coming. For B, it should be going to 2, right? Yes or no?
Yes.
But it is not giving. That is the fault of rank. So that is the reason Oracle is introduced into dense rank. Now see, this is the one. Let's take this. Now go into dense rank. Now see dense rank how it is coming. A is 1 is coming. For B 2 is coming. C is 3 is coming. D 4 is coming. If you go into rank, now you can see the rank again. For rank is coming, A 1 1 is coming, perfect. For B, it should have to come 2, but it is giving 3. That means based on the row number, it is going to deciding this. So now you understood difference between rank and dense rank. Hello? 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 So are you clear now? Difference between dense rank and rank? Hello?
Oh,
Yeah, please tell me. Are you clear now?
little bit.
No, it's not a big deal. Let me show you again. Okay, first I will take the rank. Okay, see this. This is the ranks output. Okay, ranks output. Where is this ranks output? This is the one. This is the ranks output. Okay. Let me take the dense rank output also. Okay. Take this dense rank output. This is going to dense rank output. Now this is a rank output. Okay, and this is a dense rank output. Can you compare it both now?
Mm-hmm.
Yeah. Now what you observed, madam? Differences. Here, row number. This is going to rank is going to giving the output as a based on the row number. Okay, row 1, 2, 3 like that. It will going to give. It will not going to allocate as a 2 for B. See, AA means they got a rank 1, B got rank 2, but it is going to rank is going to allocated 3. Again, C is going to 4, C4, C4 is there. D is going to rank 7 is coming. But who will going to got 5, 6? No one, right? If you go into dense rank, it will going to give on the sequence of properly. AA rank 1, 1, B is rank 2, C is 3, and D 4. Okay?
Okay.
Still you are not clear?
I think I need to do this and see once.
No. Let me show you some difference between say rank and dense rank. Google understanding our requirement immediately. Rank gives you the rank within your ordered partition. There are assigning the same rank with the next ranking skipped. Are you clear this?
Yes.
And dense rank again gives you the ranking within your ordered partition, but the ranks are consecutive. No ranks are skipped. Understood? So that is the what it is going to happen. Here it is going to rank 2 is skipped, but it is giving its rank 2 is coming here consecutively. So try to look at it and practice it, then definitely you'll get.
Okay.
So shall we start? Tomorrow we're going to start the PL SQL.
Okay.
Fine, madam.
Thank you.
All right. Thank you very much.